high-quality articles for peer-reviewed science journal. To begin the day's proceedings, I warmly invite Dr. Sepalika Sudasinghe, Director General of the National Science Foundation, to deliver the welcome address. Over to you, Madam.
Good morning, everyone. Chairperson, National Science Foundation, and also the experts who are working with us, with NSF, Professor Ajit, and also Dr. Gunaratne. I'm really glad to see you here. And also the NSF heads of divisions, and very importantly, the academic community, scientists who are interested in publishing and writing articles and improving and intend to improve academic writing skills. So this workshop we were planning, and we have seen some gaps in the process. So therefore, the head of the division, Mrs. Nadija, actually, she has taken a lot of efforts in organizing this because of the number of requests that we have received for this workshop is number-wise, it's really high, and we don't have enough facilities to accommodate. That's why we have number of participants who are interested in joining this workshop online. So let me welcome all the online participants also to this workshop. So I'm sure that you will gain skills in writing academic papers and publishing articles during this workshop. So we have designed this workshop in a way that you can be free and discuss freely with the experts we have invited for this workshop and to address to your challenges in this process. So be free and get the maximum benefits of this workshop. And also, I'm sure that Mrs. Nadija intends to organize this sort of workshops because there is a request, there is a gap in the system. So we NSF would like to address to all these gaps the requests of our academic community, because you are important, because you will decide and design where we should go in future. So with that brief note, while thanking for accepting our invitation, Dr. Anil, Professor Ajit, and we are really grateful to two of you. And also I know that another two experts will joining with our expert team from the journal publication division. So while wishing you a great and enjoyable workshop today, I hope that you will gain and you will address and you will discuss your problems in this process. Thank you very much. Over to you.
Thank you, Madam. Next, I cordially invite Dr. Sudath Samaravira, the Chairman of the National Science Foundation, to deliver the introductory remarks. Over to you, sir.
Very good morning, Director General and Additional Director, and also our Principal Officer, and also the resource persons and participants here today, and also who are joining online. I think altogether about 100 people are participating in this workshop. And also, if I am correct, after announcing this workshop with no time that slots were filled. There was a very big attraction. So that is one indication that there is a real need of writing high quality journal articles, and also people are enthusiastic, and also the need is there. So I'm from the health field. So in latter part of the 20th century, the studies showed that about 1090 divide, that is about 90% of health problems coming from the population, that is 90% of the health problems arises addressed only by 10% of the research. On the other side, 90% of the research are concentrated on health problems among 10% of the people. When it comes to the publications also, it's the same. One study showed that in the mental health, only about in some journals, only about 6% of the articles are coming from the developing world. So there is a disparity. So research-wise, yes, because of funding issues and also some capacity issues that we are having, that we are lagging behind research arena. But now we are recovering it. I think in future more and more research will come. It shows that the government also providing funds and also supporting research and innovation, not only basic research in industrial research, and also more focusing on the research becoming into practice and commercializing and making products and bringing into the country's economy. So in that scenario, publication is one of the most important thing to showcase that our findings, and also to add the knowledge into the research world, what we gather from here, and also to claim our ownership on that. For all these things that publication is necessary, publication should be done on a high impact journal to have better results, and for that good quality research articles should be printed and published. So in that case, the National Science Foundation journal is the country's only index journal in the citations that indexed these databases. So with that, you are having an opportunity to publish it here in Sri Lanka, but not limiting that. You can go ahead with the international publications. So anyway, that this workshop will be very much important for you. And I think that it will, that you are here 100. So within no time, we will be experiencing more than 100 high quality journal articles will be coming from you in future. And also we will be looking into have the similar programs in future also, and also not limited from here to you give the support if you need in future also in other aspects. So thank you very much for organizing this, for the organizers here, and also the resource personnel that who are contributing to us to have make this success. And thank you very much for you all, because you are the most key persons here. Without you, this workshop will not be a success. Thank you very much.
Thank you, sir, for the inspiring remarks. Next, we have Ms. Nadija Vikramarachich, Head of the Journal Publication Division, NSF, who will share her insights on publishing pitfalls, sharing evidence. Over to you, Ms. Nadija.
Good morning to all of you. we are thankful to all of you being here and also those who are joining online. It's very interesting and pleasure to see such a demand for this kind of workshop. So actually, I'm not going to detail anything, but I thought it's my duty to add some points to what the chairman and the director general have told you right now. So this is just basically an editorial process, flow of editorial process begins with submissions and then kind of initial scrutiny to see whether the manuscript is aligned with the author guidelines, and then pre-screening step and the peer review step. So these are the two critical points that today we are going to address. And if a manuscript passes through these two stages without much hindrance, there is no issue in getting accepted and publishing the paper by a publisher. So I will just show you actually this is what we want to highlight. I would like to take your attention to this slide, pre-screening rejections that the NSF has experienced throughout past years. You can see pre-screening means it's usually done by editorial board members, or some journals says associate editors or content editors or subject editors according to a criteria given. So I'm just displaying here the criteria used by JNSF. I'm not going to explain it because our resource persons will definitely go through those steps. So, but it's very important. If you can see this graph, you can see the increase in number of rejections over the years, starting from 39% in 2022. Now, at the very beginning, it get rejected. So it's a kind of a pathetic situation, because we know, being a researcher, how much effort you put into in preparation of a manuscript. If it get rejected at the very beginning, so what would be the situation? So this is one challenge that we observed. And then after peer review, your fate may be in one of these places, either reject, revise, or accept. So now I will show you our experience in regard to peer review rejections. So this is the NSF, we do double-blind peer review process, and mostly other journals also, reputed scholarly journals do the same, against a kind of criteria given to external reviewers. So here you can see again from 2022 to 2025, so number of percentage review rejections. This is actually process completed ones. So it's again floating around 40%, much higher than 40%, escalating to 64% in 2023. So this is again another challenge as editorial office we face, and editorial board members also. So now the next issue is, actually I'm just sharing the JNSF experience, but this is, we are today addressing generally how to improve scientific writing. And then another challenge, you don't think now, even though we accept manuscripts, the nature of the accepted manuscript after first revision, I mean the first post-review. So you can see 69% major revisions, that is the comments from the reviewers, and 31% minor revisions, that is accepted manuscripts during 2024 and 2025. So this is another critical issue we face, because if it says major revisions, it will be like a double work for you authors, as well as it will take much more time than the time you have taken to write the initial manuscript. So it would be a costly process for all of us. So therefore, this issue should also address. So actually, publishing a paper is not a individual work, it's a teamwork. It involves editorial office, authors, reviewers, and editorial boards as well. So we have to save all of us time and to put high quality paper out. So because of that, I think today's workshop's intention is to improve the scientific writing process. So our experts are here today from different universities and those who are serving Journal of National Science Foundation to help you, guide you to improve your writing skills. And we respect our authors and our researchers. So I think you will get the benefit of today's workshop. The purpose of the workshop is, I think now you will understand why we are having this nature of workshop. So with that, I conclude my note, wishing you a fruitful day. Thank you.
Thank you, Ms. Nadija. The first talk will be delivered by Professor Ajit Abesekara, Emeritus Professor at the University of Sri Jayawardenepura and Editor-in-Chief of the Journal of the National Science Foundation. He will speak on the topic, a high-quality paper can arise only from a well-planned research project. Please join me in warmly welcoming Professor Abesekara. Over to you, sir.
Chairman of the NSF, Director General, members of the editorial staff, and ladies and gentlemen, first of all, I would like to congratulate Nadija and her team for organizing this. From the applications we have received, it was clearly fulfilling a need, which is some of the reasons why proper writing is important. My point here is not really about writing, but to impress on all of you that to write an excellent paper, you need excellent material. Without that, you can't write excellent paper. So now the question is, what do we look for? There are, in the slide that Nadija put, she put up some of the things that reviewers would be looking at. But I want to pick on just two very important things. One is significance of your work, and the other one is the novelty. Those are the two things that are essential for you to have your work that you had done published. I would also like to add a clear message to this, that what I am talking about will be relevant to a journal like the JNSF, which is focused on science. It may not be that relevant to some of the other journals. In fact, we get papers which don't satisfy the criteria that we look for, but which we say will be better suited for another. I mean, say for example, development of a food product. You get people doing very careful empirical work, changing parameters and then coming up with something which meets up. Now that's good work, but it doesn't fit the JNSF because we are looking at scientific significance. There is there's a difficulty. Significance, the word significance is context-based. What is significant in one situation may not be significant in another. Another thing is health. Now, you get people doing systematic reviews and submitting them to the JNSF, which we don't accept. We say better for a medical journal because JNSF publishes only critical reviews. They are experts in a particular subject, will provide their own insight into whatever the subject matter is. So with that proviso only, please keep in mind what I'm saying is applicable to a journal which is based mainly on natural science. It doesn't mean that your article is not significant or what you're doing is not significant. Having said that, what do we mean by significance in the context of a piece of research? There are two things we are looking at. We are looking at knowledge. Is there a knowledge gap that your research work is filling? And the other thing is understanding. does it provide a scientific understanding into the phenomena that you're looking at? Without both of those things, you can't call it a scientifically significant project. Say again, using the food example, if you can look at what is the molecular nature of the changes that you're doing, particular interactions, provide some spectroscopic evidence of what you're saying, then you're now bringing the science into that. Without that, it may be significant for a food products journal, but not for the JNSF, right? Now, the most important thing to do if you are planning a project is to read about the subject matter that you're going to work on. Read about and read around. What we see is that quite a lot of the papers we get don't seem to be aware of the current status of knowledge on that particular subject that you're talking about. That requires intense work. You can't come up with a research project in 1 month or 2 months. I think you need to plan it for at least 5 or 6 months and collect the literature, analyze and see, is the work I'm doing significant? Is it going to add something to knowledge? And is it going to add something to our understanding of this thing? So that is what will provide the, remember, science keeps growing. So what you do today must provide the basis for someone else to move further. Now, there are some kind of work done which can do that, but won't still fit the JNSF. For example, a survey. Survey can produce very useful data, particularly in the health sciences, right? But it doesn't satisfy the other requirements. It may be even novel because you're presenting data that have not been published before. But unless it can seek correlations between this data that you find to provide understanding for further research, further action, then it's not scientifically significant. So what I want to say is it's not an absolute thing. It's not an absolute thing. It's judgment based on the experience of the people who are doing this. Now, just to give you an example of the importance of reading around the subject and knowing the status of the thing, I hope those who are not chemists will excuse me for choosing an example from chemistry because that's my area of expertise. But to take the question of antioxidant properties of plant materials. Now, this is a subject we started developing around the 1980s, 1990s, where Halliwell's article, which showed the importance of free radicals in all kinds of situations of health and disease. And people started looking at things which can actually suppress or neutralize free radicals in the body. So naturally, those who are working with plants started a lot of work. And there are lots of papers on expressing in vitro laboratory tests of antioxidant activity. Say in the 1990s, now it has become abundantly clear that there is very little correlation between in vitro antioxidant assays and what happens in your body. To the extent that the US in 2012, I think, stopped publishing antioxidant values of foods because it's not relevant to your diet. Right? But I'm amazed at the number of papers that we get about somebody taking a plant and extraction and then doing in vitro antioxidant assays, and then studying the phenolic content and saying there's a correlation that's been known for donkey's years. Right. So now this, I don't blame anybody, but this comes what I talk about proper planning. Now, if you read up about plant antioxidant activity, its importance, you will realize that there is no significance in it. In fact, one of the top journals in the world, the Journals of Ethnopharmacology, gives as a point of immediate rejection reporting of antioxidant values, in vitro values, without in vivo correlates. I do not know how many people working in this area are aware of that even. They give some reasons for immediate rejection of papers. And one of them is that. So that's one area.
I'm just bringing it out to the importance of reading around the subject matter and knowing whether what you're doing is making a significant impact into that area. It can be a small impact. I mean, it doesn't have to be very extensive, but it must be significant. It must provide a gap, some gap in knowledge. It must provide answer to some gap in knowledge, and it must also provide understanding into the phenomena. Another example is flavonoids. Now, there's a lot of talk about the health protective effects of flavonoids and relating it to the antioxidant activity. Now, the research is showing that flavonoids do not exert an important antioxidant effect on your body by their own antioxidant activity. They act as signaling molecules within cells, and they interfere with various enzyme cascades in your cell. So now, if you don't read about this, if you're doing some work involving flavonoids, you need to read about flavonoids. And for those of you who are students, don't just accept what your supervisor says. Now, I have a lot of sympathy for university project supervisors, given the facilities we have, the funding we have, they have to select projects. So they will give you all projects, but those are training projects. They help you to research something into something which had not been done before, and you learn to interpret results and learn to see where your research can go. That's all very good. But now we are talking about writing excellent articles. And again, when you say excellent articles, where are you targeting it? What may be an excellent article for your departmental journal, where you can write about your research project, may not be the excellent article for a high-ranking journal. And what is an excellent article for the JNSF will probably not be an excellent article for a journal like the Journal of the American Chemical Society or JNSF. So remember, all these are relative values, and what I'm saying mainly just applies to our situation. Okay. So the one other important, I think so I spoke about significance, I spoke about novelty. Now that sounds important. Now, again, that is listed as one of the reasons for immediate rejection by ethnopharmacology. If you just repeat what somebody has done, okay, we all know that plants have. Let me take an example now. What's the craze about green synthesis of nanoparticles? Now, if you take a solution of silver nitrate and you add a reducing agent to it, you will get some silver nanoparticles, well known. And all plants have got reducing matter, phenolics. So virtually any plant extract will give you some silver nanoparticles. You put it to silver nitrate thing. So there is nothing new in it. So somebody reported a paper on plant X. If you take plant Y and do the same experiment, not significant, right? Then, important point about methodology, which I can use again from this example. The methodology that you use, I'm talking not about methods, Methods have to be good, then this thing, I'm sure people can do that. The methodology, what is the approach you're going to use to get the information that you want? Is the methodology relevant to that? Now, again, taking an example from the silver nanoparticle business, there are so many papers. Papers are published in all kinds of journals, so you can't really take that. But that's another thing. When you're reading articles in journals, please also check the quality of the journal. Because nowadays you can publish anything in some journal, somewhere or the other in the world. So you need to be aware of that. But okay, now if you want to show that your green synthesized nanoparticle has better antimicrobial activity than a normal chemically produced, say by sodium borohydride reduction of silver nitrate, what should be your control? Your control has got to be a conventionally produced silver nanoparticle with what you have produced. It can't be the plant extract. Because when you do antimicrobial tests, if there are compounds of the plant extract absorbed on the silver nanoparticle, it will exert antimicrobial effects. But silver particles by themselves exert a significant antimicrobial effect. Right? So the idea of a control is very important in choosing your methodology, particularly for biological work. Control is absolutely essential, and you must have the correct control. So it is surprising to find these basic things wrong in some other papers. Now, if these things are not right, if, for example, if your methodology is not appropriate for the result you get, depending on the title of your paper, sometimes the title says something, but the conclusion is a different thing. I'm sure Dr. R.D. Gunrath will have something to say about that in writing, but I'm not talking about writing. But I mean, these things have to be correct. You must have the material to write an excellent paper. Otherwise, however good your writing is, if the substance is not there, then it's not acceptable. So once again, I'm very happy to know that there are so many of you attending this, and I'm sure that the resource persons of the workshop will give you very important advice. But I just like to pass this message that when you're doing a research project, please read around the subject and make sure that if you get some results, that it will have a meaning. So two things you should ask yourself. What, if I get the result, what will it show? What will it prove? You know, if it is not something significant, if it is show that plant X also reduces silver to silver nanoparticles, it's not very significant. Other thing is, are my methods going to give me that the answer I need? So with that, I shall stop. I wish all of you all a very educative and enjoyable workshop. Thank you.
Thank you very much, sir, for that enlightening talk. Next, we are pleased to invite Dr. R.D. Gunratna, retired senior lecturer, Department of Chemistry, University of Colombo, former director and CEO of NASTEC, former provost of Slintech Academy, language editor of the Journal of the National Science Foundation, and former editor of the Journal of the Sri Lanka Association for the Advancement of Science. He will speak on the topic of journal article writing, avoiding common mistakes. Please join me in warmly welcoming Dr. R.D. Gunratna.
Thank you. While waiting for my presentation to appear on the screen, let me take this opportunity to wish all of you, including the people who are joining us online, a very good morning and a very successful day. Thank you. Okay, the screen in front of you is not as large as one would wish, so I hope the people at the back can clearly see what I have written. I usually try to have a decent sized font so that people can make out what's on the screen, and I hope that that will be useful to you. Now, how does one do this? Does that work? Thank you. Well, thank you. Perfect. Technology is not always easy to use. Okay, so Professor Abhay Sekara told you something very important about the quality of what you have to do before you write your article and submit it for publication. My job is to talk to you about the article itself. Now, it has been my experience that some very good scientific work, in some cases, fit to be published in international journals, are rejected because they are written in bad English, to put it very bluntly. Okay, they're not well written, and I don't just mean the structure of the article, though there can be mistakes there, but just the quality of the writing. International journals and the journals of the National Science Foundation strives to reach that standard. Want the articles to be written in good language, and the language in most cases happens to be English. Right? So if you want to submit your paper, not just to the NSF journal, but to any important journal based in, say, the UK or the United States or Australia, if you don't write it in good English, they will simply send it back to you. Okay, now, there are many reasons why this could happen. One could be just bad language, right? Poor grammar, spelling mistakes, broken English. Every journal has a set of guidelines, and if you don't follow those guidelines, you're going to be in trouble. And then in addition to technical issues of writing like grammar, there's actually the way you write. Right? A good article should be written so that it flows logically from the beginning to the end, as though you were telling a story. Now, if you jump around the topics and it's not clear what you're trying to get across, well, we would call that bad writing. Okay. Then, of course, there are other reasons why your paper might be rejected, and some of them Professor Abeysekar has already alluded to. For example, lack of originality and an inability to justify your study. And then there are other kinds of mistakes, like inadequate information in the methodology section. So you would have done a wonderful piece of work following the advice you have been given, and still find it difficult to get your work published. Now, my role in all of this, right, a few years ago, about 4 years ago now, maybe 5 years ago, the National Science Foundation apparently, and you can correct me on this, Ajit, realized that the quality of the language in the papers that were being published left something to be desired. So they decided that they needed someone to just deal with the language issues. Now, I don't claim to have any professional expertise in that. I'm a chemist, an organic chemist, just like Professor Abeysekar. But my English was considered to be pretty good. So I was encouraged to apply for this position when it was advertised, and then I was recruited. For the last 4 years, most of the papers not all, but most of the papers that were published in the Journal of the National Science Foundation came to me to improve the quality of the language. So they had already been accepted. And my job was to correct the English. On the way, I would sometimes find a few other errors, and sometimes these papers would be returned to the author to correct those errors as well. Okay, so that's my contribution to this. I just want to quickly show you this slide, which I borrowed from a course that I teach at the CINEC campus to undergraduate students on the history and philosophy of science. Right now, this is an outline of what we call the scientific method. Why is it important? It's important because this, or something very like it, is what your work is based on. When you're doing research, you're following the scientific method, right? In theory, the scientific method starts with observations at this corner of the screen, right? The observations may themselves be facts, or they may lead to facts after they have been analyzed. The hypothesis is the explanation of those facts. Now, the purpose of science is not to collect facts, is to explain them. Right? So you have different ideas of why something may be happening the way it's happening, and we call those ideas hypotheses. And the hypothesis allows you to make a prediction. If you're right, then if you carry out an experiment like this, you should obtain such and such a result. You do the experiment, you get a new set of observations, and maybe they'll support your hypothesis, or maybe they won't. If they don't, you have to either modify your hypothesis or change it. If they do, your hypothesis may eventually become a theory. Now, where in this cycle do you publish a paper? You can actually publish a paper almost anywhere, but for it to be significant, it must at least support your hypothesis. In other words, when you're carrying out a research project, you have some objectives in mind. If your objectives are simply to collect some facts, there are places where you can publish those, but according to what Professor Abeysekera said, the NSF journal is not one of them. Okay, so publishing at the level of the hypothesis or the theory is what you should be going for. And that means that in your paper, having presented all your results, right, all your facts, you must then interpret them to show that they support a hypothesis or they do not support a hypothesis, or what they mean. The absence of that interpretation would be a fatal flaw in your paper, at least for purposes of this journal and many international journals. So when you write a paper, the first thing you write will be the introduction. And the introduction can make or break your paper. Okay? Now, in the paper itself, the abstract will come before the introduction, but strictly speaking, you write the abstract only after you've written the paper. So the abstract is a summary of your entire paper. So you would probably start by writing the introduction. Right? Now, the introduction is there to justify your work. It's not the only thing it's there for, but that's the primary objective. Right? So in the introduction, you must explain very clearly why what you're doing is important and worth publishing. What is the gap in the scientific knowledge, the body of scientific knowledge that you're trying to fill? Why are you doing this research? Why is it important? Why is it new? Why is it original? Is it original? Okay? And to explain all that, you must have a very clear idea of where the whole thing came from. Now, science does not start, well, it hasn't for a long time anyway, with one individual getting a bright idea. Right? Virtually all the science that's done today, and the science that has been done for hundreds of years, is based on work that went before. Even Isaac Newton said that if he could see further than most people, it was because he stood on the shoulders of giants. And he was referring to the people who went before him. Because you must know what other people have done in your particular area of research. And you do this by carrying out what we call a literature review, which is relatively easy to do these days because of internet access, even though to get hard copies of journals is prohibitively expensive, but through the internet and with some help from your friendly librarian, you should be able to get copies of any paper that your search, your internet search, tells you is relevant. And Professor Abeysekera has already said how important it is to read all this stuff for months, maybe, before you start planning your research project. Now, if you don't do all this and put it down in your introduction very clearly, at that stage, you will be in that percentage, I can't remember exactly what it was, of papers that get rejected upfront by the editorial board itself without even being sent to reviewers. You need to convince the editors that your paper is worth reviewing. Not publishing, not yet, but just being sent to the reviewers. So that's the first barrier. Now, your literature review should cover the scientific background. What is the work that has been done? What are the basic principles of science that are applicable? What are you trying to do with them? What's your objective? If you like, what's the hypothesis you're working on? And how are you planning to support that hypothesis? Right? And that's where the originality, hopefully, will come in. You must make sure that the prior work is clearly described and the people who did that prior work are given credit. That it is considered to be very selfish not to acknowledge what other people have done. And your reputation will be damaged if people realize that you're trying to take a lot of credit for other people's ideas.
Recording in progress.
Oh, that's nice. Okay. The scientific background is not the only background that might be relevant, right? There are historic aspects. There are social aspects. If you're dealing with, for example, a medicinal issue, coming up with a new drug maybe, you can show that it's important because it addresses some important health problem, right? Or there may be economic aspects. You may be on the verge of coming up with something that some company will commercialize and make a lot of money out of, right? So these are all things that can be addressed to show that your work is important. So a good introduction. A good introduction is absolutely essential, perhaps the most important part of your paper for purposes of getting it published. Now, if you follow the NSF's guidelines, usually the next part of your paper will describe what we call the methodology. In different journals, this comes in different places, sometimes more towards the end. It goes by different names. It might be called experimental procedures or materials and methods or something like that. But basically, it describes what you actually did. Now, at the heart of science, this is part of the philosophy of science, right, is a notion that what one scientist can do, someone else can repeat if they want to. Maybe to confirm that you actually got the results that you got. How would another scientist repeat your work? You have to provide the necessary information in the methodology section. So your guiding principle has to be, right, that you must provide enough information that a reasonably experienced worker, but not an outstanding expert, but a competent postgraduate student, for example, in your area of work, can repeat the experiment and hopefully get the same results. Scientists trust each other, but they verify sometimes. Okay? If there is a piece of work that only you can do, that no other scientist can ever do, no matter how hard they try, it's not science. Right? That's, I don't know, something else, religion or something. Okay, so you must provide the information in your procedure that would allow, like I said, a reasonably experienced worker to repeat your results. Now, that does not mean that we have to provide every little detail. Okay, there are some procedures which are well understood. For example, in my line of work, okay, I'm an organic chemist, we sometimes use a technique called solvent extraction. So you don't have to say, I put this much of this solution in ether into a separatory funnel and so much of the aqueous solution of something else, and I shook it like this, and then I set it aside for the layers to separate and I drained off the lower layer. You don't have to say all that. Any competent organic chemist know that that's what you did. Okay? It's enough to say the solution was extracted with such and such. But you must say that. If you use an absolutely standard method, which is reasonably available in the literature, just give the reference. Maybe good enough. But if you're going to describe the procedure that you actually followed, maybe because you made some changes, right? Indicate as concisely as you can. I don't give unnecessary details, but indicate what was actually done. Now, in writing a journal, like in writing a thesis, for example, we use what's called the passive voice, right? And we use the past tense and we use the third person. I hope all of you understand what those words mean, because sometimes I wonder. Right now, in the passive voice, the focus is on what was done, not who did it. So you do not say, for example, I extracted this solution with so many milliliters of aqueous something or the other. You say the solution was extracted. It doesn't matter who did it. Okay, so we use the passive voice. This is almost unique to scientists. If you go into the humanities, or some social sciences also, you will find that they don't like the passive voice. The person who did it is very important. They always prefer to use the active voice, which says, I did something or he did something. Okay, but we don't do that. In science, we use a passive voice. We use the past tense because it was done. We use the third person, obviously, because there's no I, right? It's the solution or some object, some experiment that was carried out. Make sure you give the relevant information that someone will need to repeat the experiment. Quantities of reagents, number of replicate samples, controls, very important. Professor Abesekar talked about controls, right? Locations, if you're out in the field, exactly where did you collect the sample, all that information should be provided. If you're using chemicals, you don't have to do this for standard laboratory reagents, okay? But in many cases, you should give the source of the chemical and the grade, right? Was it analytical grade? Was it 95%? Whatever, right? To give that kind of information so that the next person who wants to repeat or to use your experimental procedure will know what to do. Make sure you use appropriate nomenclature. Normally, we like to use scientific nomenclature, but it doesn't have to be the most formal version of scientific nomenclature. In fact, in organic chemistry, and I'm using these examples from organic chemistry, there's a solvent called acetone. The official name is propanone, but if you say propanone, no one will know what you're talking about unless they look it up. Okay, most people just say acetone. If you're using non-standard apparatus or apparatus that is not commercially available, describe it. Right? If you design the apparatus yourself and built it, like people do in some areas of engineering, give a little diagram. Many people are very good at that. Most of the papers that have come before me contain all that information. Make sure you provide it. Okay? But if you're using standard instrumentation, just say where you got it, which company, which part of the world, model number, all that information should be provided. If what you did had some unusual problems like hazards, right? You don't want some unsuspecting graduate student repeating your experiment to blow himself up. It would prey on your mind for the rest of your life, right? So make sure you indicate very clearly somewhere that precautions were taken, right? Hazards can include toxic substances, explosive substances, highly flammable substances. Just mention. If you had to use protective equipment, mention it, right? Any special problems associated with waste disposal, it is worth including that as well. Okay, so you did the work. You got some data. Very often, your data is a set of numbers. You made measurements, you came up with some numbers. You process those numbers, nowadays probably using a computer, at least a calculator, I'm sure. Okay, and you came up with some numbers which are your results. Now, not all results are quantitative. Not all results are numerical. Some are observations in biology and some areas like that. It can be an observation, right? A qualitative one. But very often, you may have an entire table of numbers that constitute your data. Now, how accurately did you make your measurements, and how accurately do you present your final results is an important question that most people, in my humble experience, ignore. They don't worry about it. They followed some procedure. The computer did the calculation. You just write down whatever the computer told you without worrying about what it means. And I have a real problem with that. Maybe I'm the only one, but I have a problem with that, which I want to share with you. Okay? So every measurement you make has a certain level of accuracy and a certain uncertainty. We sometimes call this experimental error, but I like to avoid the word error because the ordinary person, the lay person, interprets error as a mistake. Oh, you made a mistake. And you can't go, for example, to a court of law as an expert scientist and talk about experimental error because the lawyer on the other side said, oh, you admit you made a mistake. No, you can't do that. So we use the word uncertainty. Okay? And every measurement you make and every result you calculate from that measurement has an uncertainty. The highest level of accuracy you can achieve is the most accurate measurement you can make. And some instruments will give you up to 4 figures. Okay, 4 significant figures, 4 digits of accuracy. The last digit is uncertain. Others may be certain. You're quite sure of them, but that last digit could be off by 1 or 2, plus or minus. Now, in practice, we have a thing called random error, right? So however accurately however carefully you do this, because some fluctuations in the electrical supply or a different way in which you looked at your burette or some other issue like that, right? Some additional errors creep in and they can be up or down, they can be plus or minus. We call this random error. And the actual level of uncertainty is increased by this, and everyone knows that. Which is why we usually, when we are taking a measurement, we don't stop at one measurement. We take a whole bunch of replicate measurements, typically some number between 3 and 6. And the more the better, but of course, more measurements means more time spent working on it. And then we calculate something called a standard deviation. And we report the final result as the average of all your measurements plus or minus a standard deviation. Okay? Now, a lot of people do this in a very, very routine way. what you need to understand that is that a standard deviation or some other number you derive from a standard deviation, like confidence intervals, for example, right, can be derived from the standard deviation. These things are actually a measure of the uncertainty in your data. Now, because the standard deviation is a measure of uncertainty, it's absolute idiocy to calculate a standard deviation to a high level of accuracy. Why are you trying to be accurate about something that is inherently inaccurate? Okay? So normally a standard deviation should be, statistical purists will tell you there's one figure, one digit. It's a final digit in your, it should match the final digit in your average. It's a measure of uncertainty. You can't know it with certainty, and certainly you can't know your actual result, your calculated average, with certainty. It doesn't matter how many figures your computer will calculate it to. You can set an Excel spreadsheet to calculate to 15 digits. Are you going to report them all? No, it's idiotic to do that, right? But people still report more digits than they should. Okay, so what I'm saying here is that you can report your standard deviation to at most 2 figures. And I'm saying 2 because most human beings have a psychological problem with stopping at 1. I think it's a psychological problem. Right? You don't want to say plus or minus 0.02. You want to put in one more figure somehow, because otherwise you think there's something wrong. Actually, there isn't, but people have an urge to put in more numbers. They think that the more numbers you put, the better. Okay? So we will accept 2 figures, 2 significant figures in a standard deviation. But then that should limit how many figures there's going to be in the average that you report. Now, to make all this clear, on my next slide, I've just given a number. Okay, that's a random number. I just got it out of my head. Okay, so let's say that's the number you're reporting, 728.462. Your computer gave you that number. When you put in all the measured data, it came up with this as the average. Your computer will also calculate the standard deviation to have many figures as you want. And by the way, I have seen, not this exact number, but I've seen numbers just like this in papers that come before me to edit. It's not, strictly speaking, my business to edit these numbers. I'll be very honest with you. It's nothing to do with the English language. But I always send a message back to the editorial staff saying, this doesn't look right. Okay, so you can see there are 2 digits there in green. I hope all of you can see that from the back. The digit 8 in 728.462 and the digit 2 in the standard deviation, which has been calculated as 2.6038. Now that's a very, very accurate standard deviation. Okay, but the important digit there is the very first one. It's the only one that matters, because that tells you that that's the digit that matches the 8 in 728, right? That tells you that the digit 8 is uncertain. It could be up to 3 one way or the other. That number could actually be 725. It could actually be 731. It's somewhere in between. The actual number is somewhere in between. So if it's somewhere in between, is there any sense in putting down the decimal places, 462? Right? You don't know them. You can't report them because you don't know them. All you can say is that your final result is somewhere between 725 and 731. In other words, you should really report your result as 728 plus or minus 3. Now, like I said, Most people don't want to have only one digit in the standard deviation. It makes them very uncomfortable, right? So we will accept a second digit. Instead of 3, we'll say 2.6. And it makes absolutely no sense to go beyond that. So then, of course, your final result would read 728.5. We are rounding it off. We are rounding off the fourth digit, plus or minus 2.6. That's the only thing you're justified in saying. Okay? Don't feel that you have to have a certain arbitrary number of decimal places that in your reported results. Don't feel that the more numbers you put, the better. Don't feel that you can have some extra numbers in your standard deviation because it implies that it's more accurate. It's not. Okay? These are sensible thing to do. And if you understand what you're doing, this is what you will do. Because you understand the limits of your work. You understand the limits of your experimental procedure. Now, let's call them technicians, okay? Many technicians don't understand it. They're just following a procedure. Following a procedure, here's the data, put it into the computer calculates the results, I report the results. Technicians do that. Sometimes numbers like this get reported at international conferences or even SLA's conferences. And once in a way, I've challenged numbers like that. And very senior people have told me, oh, we just followed the procedure. And yes, they did. Just like a technician. Okay? So the difference between a technician and a scientist is that a technician follows the procedure without thinking about it. A scientist understands what the procedure means and interprets it. Okay? So please keep that in mind. It's meaningless to have all those unnecessary decimal places. Don't report them. Okay. So we've done the introduction, we've done the methodology, we've got the results, and now you're going to explain what the results mean. This is called the discussion. There are common mistakes that people make in the discussion. And many of these, of course, are usually dealt with before the paper comes before me. So in most of the papers I have read, the discussion has been okay. But even then, I find some issues. Okay, so you have some objectives which you have stated up front in your introduction. This is what you're trying to do. You have some results. How do you connect the results with the objectives? How do you connect your results with your hypothesis? That's the whole purpose of doing this. Okay, if you fail to do that, you have failed. Simply restating the results rather than interpreting them is not a discussion. You got some results, you presented them, then you repeat that all over again and you call it a discussion. Now, some people, of course, want to have a very long discussion. They bring in, let's call it unrelated information, some other stuff, which may or may not be relevant, but then you're discussing something other than your results. You're bringing maybe some speculation into the discussion rather than your experimental results. Okay? And some people, when they write this, are interpreting the results even before they present them. Right? Now, of course, you know what the results are, but the reader doesn't. The reader sees you making some declarations, and the reader is wondering where did they come from, and the results follow. So make sure you do this in the right order. Okay, present the results and then show how they support your hypothesis, they don't support your hypothesis, so that's also important, right? And your objective should not be my hypothesis is correct at all costs. Right? So you quietly ignore any results that don't support your hypothesis. That's actually dishonest. It's scientific dishonesty to only select those results that support your hypothesis. You must interpret all the results and show these results support the hypothesis, these results don't, these are neutral, what does that mean? Right? So you must consider all your results, and you must also compare your results with similar results obtained by other people, which of course you would get in the literature. Okay, you can say, my results support the results that so-and-so got in such and such a country, in 2018, but they seem to contradict this person's results. So you can have a nice discussion along those lines. And finally, at the end of the paper, you have a set of conclusions. Now, the important thing about the conclusions is make it short and sweet. Okay? A quick summary of your main findings and what they imply. Okay, either my results strongly support the hypothesis or they don't. What's the next step, if there is one? Right? Do not go beyond the actual findings. I have seen in places where someone had some speculations in the introductory part of the paper and then repeated those speculations as conclusions at the end of the paper, with nothing in between, no results. Right? But the original speculations, which were just speculations, are repeated as conclusions, which is wrong. And of course, your conclusions should not ignore important observations, particularly ones that don't support your hypothesis. Okay. Now, what you should avoid doing, and I will talk about this later, is simply copying and pasting sentences out of your discussion, for example, into your conclusions. That people do that, and they copy and paste the same sentence into the abstract also. Right? So that becomes very boring and repetitious. Put it in a different way. Okay. Sorry, I seem to have got those in the wrong order. Never mind, we'll just address this very quickly. I'm not going to talk about what the guidelines are that you need to follow. The NSF has its guidelines, its style, if you will, for writing its papers. You need to make sure you follow those guidelines. Right? You have only yourself to blame if you didn't follow the guidelines and your paper got rejected because of that. Right now, there are guidelines for references, are a very standard one based on something recommended by the American Psychological Association. A lot of people use the APA format for references, especially in the social sciences, but also in some of the sciences. Chemists don't, by the way. Most chemists use different formats for references, but the NSF journal uses this format. You can get more information about that from that website. Okay, so you finish writing the paper, and that's when you write the abstract. Now you know exactly what you have written, so it's time to summarize it. Remember that summary goes up front. The first thing that a reader sees is the abstract. And the purpose of the abstract is so that the reader, person reading your paper, can decide whether or not to take the time to read the entire paper. The abstract, half a page maybe. The entire paper, 20 pages. A lot of time to read, and absorb and understand. Is it worth my while? Is this paper so important that I should read the whole thing? Or can I just get a gist of it from the abstract and move on? The time is short for everybody. Okay? So your abstract should do two things. Of course, it should give a gist of what's in the paper, and maybe it can tempt someone into reading the paper. Okay, so it must contain a very concise summary. It can't be very long. Objectives, the important findings, the key findings. Okay, not tables and tables of data, obviously, but the key findings, including the quantitative ones, if they are relevant, and the conclusions. Try and do this without cutting and pasting lengthy passages from your discussion or even from your introduction into the abstract. Quick summary is all that is needed. Don't spend time discussing the methodology in your abstract unless the methodology is what your paper is all about. Sometimes you can invent a completely new technique for carrying out an experiment, and your paper really will be about that technique. In that case, of course, yes, you can talk about the methodology, but otherwise you don't. Okay? And then right at the end of that, you're going to select some keywords. The purpose of the keywords is to allow quick searches. The keywords should be specific to your paper, to the work done. So don't use common terms, ordinary terms like comparison or random, which may appear in your paper somewhere, but don't use those words as keywords. If someone searches for comparison, they are going to come up with 3 million hits. Okay, so that's not going to be helpful to you. Okay, so that's the paper. Okay, now, if you successfully wrote all that, your paper got accepted with or without some changes. Now, the next question is the actual publication. When the paper gets published, printed out, or maybe turned into a PDF document and kept somewhere online, it must be written in good language. Sometimes, if it was written in really bad language, it might have been rejected. Sometimes you may be asked to correct or improve some of your language. Right? I have had colleagues at the University of Colombo, at Slintech, in other places, who had good papers rejected because of language issues, and they were accepted. These are by international journals. They were accepted once the language issues were corrected. In fact, I spent a lot of my time editing other people's papers so that they would be accepted. Okay? So there are some important things to know about. Now, be aware that minor errors will be dealt with by me or by the next person that the NSF hires as a language editor, right? But the more time you spend cleaning up your language and making sure that you write good English, the easier the job will be for the language editor, whoever that may be. So these are some of the issues that I have seen. Okay, I see grammatical errors, sometimes simple ones, and they shouldn't be there. All of you have studied English as a second language. Okay, it's not your first language, maybe, but you should be able to, you may not be superb writers of English, but you should be able to competently avoid grammatical mistakes, right? Alongside those, poor sentence structure. We call that syntax. Some of the errors include inconsistency in using tenses, mixing up the past tense and the present tense, usually. Mixing up the active voice and the passive voice. A lot of people are very uncomfortable with using what we call the definite article. So I want to spend a little time on that. The word "the" in the English language. There are some mistakes occasionally that I see in punctuation. The most important, the most common mistake is confusing the role of the colon and the semicolon. Right? So I'll talk about that. And then there are some words whose meanings people are not always clear about. And one of the common problems has to do with what we call mass nouns. Don't worry, if you don't know what that means, I'll tell you. And finally, the NSF prefers to use British spelling. In fact, I spend a lot of my time correcting American spelling into British spelling, but you can do that yourself. Okay, so a very common grammatical error is the lack of understanding between the subject and the verb. Okay. Now, English is actually a very easy language to avoid this mistake. You go to almost any other language, including Sinhalese, right? I can't speak for Tamil because I don't speak Tamil, but maybe Tamil also. But certainly most of the other European languages, French, German, right? The relationship between subjects, verbs, adjectives, very complex. There are lots of rules. English doesn't have them. A subject is either singular or plural, and the verb is either singular or plural, and the only important different form of the word is the third person singular in most verbs. In most verbs, the third person singular is different from everything else. So you say, I do, you do, but he does or it does. We do, you do, and they do are the plural forms. Right? So you have to look at your sentence. You only have to worry about singular and plural. You don't have to worry about whether it's masculine or feminine or anything like that. Right? So every sentence, every simple sentence has a subject and a verb. Now, there are many situations where you take several sentences, which are referred to as clauses, and combine them into a bigger sentence, which can be called a compound sentence or a complex sentence. And I'm not going to go into what these things mean because we don't have time for all that, right? But if you really want to do a serious workshop on grammar and writing style, inform the NSF, and I dare say they'll organize it for you. I'd be happy to contribute. Okay, so these clauses, which are independent sentences, are connected by some kind of a conjunction, such as the word and, or but, or there are other conjunctions, if, whether, and so forth. Okay? So each clause, each contributing sentence has its own subject and its own verb. They may be separate or they may share the same subject or the same verb. For example, the sentence, I went home and had my dinner. Right? Two sentences there. I went home, I had my dinner. Right? So we can combine them with and. You don't have to repeat the I. I went home and had my dinner. It is understood that the subject of the second clause is still I. Now, let's talk about the kind of simple mistake that people make when writing, where the subject and the verb don't agree. Okay? Look at the two sentences right at the bottom of the screen, and I'm sorry if people at the back, can you see? You can all see the sentences? Thank you. The mixture was stirred and 50 milliliters of concentrated hydrochloric acid were slowly added. Were slowly added, right? Now, in the second sentence, the bit following the and, it should be clear that the subject is 50 milliliters. Now, milliliters, although I've used the abbreviated form, is plural, and therefore the verb has to be plural. Were slowly added. Now, you can say the same thing in a different way. You can say the mixture was stirred and concentrated HCl, and you can get the quantity in parentheses, 50 milliliters, but concentrated HCl was slowly added. Why is that? Because concentrated HCl is singular. It's not plural. So the verb has to be singular. It's the same thing. You can decide how you want to write it, but whichever way you write it, make sure you use the correct verb. And the kind of mistake I find people making where they use the wrong verb and say 50 milliliters conc HCl was slowly added. Okay? So that's a very trivial example, but it highlights the kind of thing I have seen. Let's talk a little bit about the past tense and the present tense. We don't normally have to worry about the future tense in the scientific papers. Any work that has already been done, whether by you or whether by somebody else in your literature review, must be described in the past tense, because it's past. Okay? In the methodology section, likewise, if you are describing a procedure that you actually carried out, that's also in the past tense. It's over. You can use the present tense to describe existing concepts, the state of the art, work that is currently ongoing. That's in the present. Don't mix those things up. There are some people who write the methodology section in the present tense. Right? They don't write it in the passive voice. They write it in a different style called the imperative, where they say, do this, add this, mix this, stir this. That's not how a methodology section should be written. Right? So just pay a little attention. There are situations where I have had to correct tenses in multiple sentences in some of the work submitted. Okay. Another common problem, not understanding the difference between the active voice and the passive voice. This is a very interesting problem because, I have found that it occurs even in Sinhalese writing. Right? And Sinhalese, of course, is the native language for the people writing it, but nevertheless, they seem to be unclear about the active voice and the passive voice. So let me just remind you what this means. The active voice is a declaration of doing something. Let us say, I killed the dog. I killed the dog. That's in the active voice. The passive voice changes the object into the subject. So the dog is the object of the first sentence. You can say the dog was killed. You can even specify the dog was killed by me, but even without the by me part, the dog was killed is a complete sentence. But the dog has gone from being the object of the sentence to the subject of the sentence. Okay, so that's a passive voice. Something was being done to something. Now, like I said, although our colleagues in the humanities may sneer at us sometimes, they really do, right? They can't understand why we scientists are so keen on using the passive voice. But in science, the passive voice is really what works. And that's part of our whole philosophy. The philosophy that the person who did the work is not important. The work done is what's important. Right? Any work done by a particular scientist can be reproduced by another scientist. If it can't be reproduced, it's not science. Okay, so that's why we use the passive voice. We never allude to ourselves. So look at that sentence I have put there. That sentence is a compound sentence. Okay, there are two parts to it. The ore was extracted with dilute nitric acid. One sentence. The second part of it is, and analyze the molybdenum content using, well, AAS, of course, is atomic absorption spectroscopy. Sorry, I'm using chemistry examples. That's what I am. And many, many times, almost every quarter, there'll be a paper in which I come across a sentence or two like this. Okay? Now, the first sentence, the O was extracted, is in the passive voice. Something was done to the O. They don't say the O was extracted by the graduate student in the lab, but the O was extracted. The second sentence has a verb, analyzed, in it. And it's not clear what the subject of that verb is. Okay, now in the English language, there's one important thing that doesn't necessarily apply to other languages. The order of the words is important. The normal order is subject first, then the verb, and then the object, if any. That's the order in which a simple sentence is written in English. If you change the order, for example, you put the verb first and then the subject, it becomes a question rather than a declaration. Okay, so subject first, then the verb, then the object. And in that second sentence, there appears not to be a subject. There's nothing in front of the word analyzed. Now, if you go back to my previous example here, I went home and had my dinner. It's usually understood that the subject of the first clause is also the subject of the second clause, since no other subject is given. Okay, so following that theory, you would conclude the O was extracted with dilute HNO3 and the O must still be the subject. So the O analyzed the molybdenum content using AAS. And that, of course, is sheer nonsense because an O can't analyze anything. Only a human being can analyze something. Okay? Or maybe a robot using artificial intelligence, but something akin to a human being. An O can't analyze. So apparently that second sentence doesn't have a subject. And it's written in the active voice, and it makes no sense. Right? And you have the impression that the person writing this sentence really wanted to say, and I analyzed the molybdenum content. But that's an active voice. We don't use the active voice. In fact, you don't use the active voice with the passive voice in the same sentence. So you need to change that second part also into the passive voice. And that's actually very easy to do, right? Active voice or passive voice, the subject comes first. So if what was analyzed was the molybdenum content, you put that in front and you solve the problem. And the O was extracted with dilute HNO3 and the molybdenum content was analyzed using AAS. You don't even have to say was, right? Because was is there in the first sentence, it's understood for the second sentence. You can say the O was extracted with dilute HNO3 and the molybdenum content analyzed using AAS, and that will work. A very simple change of word order, and you have a perfect compound sentence in the passive voice. Okay? But a lot of people don't think like that. So I get a lot of sentences where the active voice and the passive voice have got mixed up. Something to avoid. Now we come to maybe the most common mistake. Very difficult one. Okay? The definite article, the word the. Now, I think part of the problem is that most of us speak either Sinhalese or Tamil. I can't speak for Tamil. Okay, I don't understand the language, unfortunately. But in Sinhalese, we don't have a corresponding word. We don't have a definite article in the Sinhalese language. In fact, many languages in the world don't have it. Okay? European languages do. Well, for the last maybe 1,000 years or so. And it's there in Arabic. I don't know about other languages. But if you're a native speaker of Sinhalese and maybe Tamil, you're not used to this. Right? Now, unfortunately, the way you use the word the is really governed by usage. It's the rules, if you will, I don't, there are no real rules, but the way you do it really differs from language to language. The English do it in a particular way, the French do it in a different way, the Italians have yet another way of using their corresponding word for the, right? And most of the languages have more than one word for the because it changes based on whether it's masculine or feminine. So how do you do it in English, right? Really, the more you read in the English language, the better your ability to use it will be. But leaving out that word the, or using it incorrectly, in other words, putting it where you shouldn't put it, is maybe the single most common mistake in journal articles, in theses for that, in student theses for that matter, which I have had to correct. And not just me, but a lot of language editors say that this is the problem they face. Okay. Now, basically, you use the word the when you're referring to a specific item or a specific set of items, right? If it's a single item that's not specific, you use the indefinite article a or an. If it's a bunch of articles not specified, you don't use an article at all. You don't use the, you don't use a. But if you are referring to a specific item, singular or plural, doesn't matter, right? That's when you use the word the. Now, here are some of the situations where you will use the. Okay? So, in a particular sentence, if a particular item is mentioned for the second time, then we know what we are talking about. We know which item it is. That makes it specific. So, I took a bus to town. Okay, the bus has already been mentioned. But the bus was very slow. Now, when you say the bus, you know which bus you're talking about. The bus you took to town. With what we call superlatives, which basically means the best, the worst, the greatest, the highest mountain in the world is Mount Everest. Or what we call ordinals. Ordinals are adjectival forms of numbers like the fourth, the third, as opposed to 4, 3. Okay? We use the word the with those types of words. Right? When you're being specific, you use the word the. If you're talking about knowledge that is shared, in other words, you're talking to someone about something they know about, you can use the word the, right? So the photocopier in the office. Okay, you're working in a particular office. Your friend knows what you're talking about. Phrases that contain of the price of graphene. Okay? And in science, theories like the Doppler effect, but not ones with a possessive in them. Possessive means an apostrophe S. So you don't say the Darwin's theory of evolution. At least you don't in English. You would in Italian, by the way, but you don't in English. Right? So Darwin's theory of evolution, but the Doppler effect. Right? So and so's equation. Like that. So those are the kinds of situations where you would use the. Use the when you're sure that it's a specific thing that you're talking about. Don't use the if it's something general. Okay, I talked about semicolons and colons. How do we use this? A semicolon is like a more powerful comma, a comma on steroids, if you like. Right? We use it to break a sentence into parts that are also sentences. Right? So HPLC is one of the most powerful separation techniques available. Sentence. Now you want to say something more about it. Right? So you But you can do that without starting a new sentence. You put a semicolon and say, however, solvent recovery or disposal is a limiting factor. So that's just an example I've given you, but basically you can use a semicolon to separate clauses in a sentence. Okay, a more rare use is to separate a list of items if one of the items already has commas. Normally use commas. In a list of items, you would normally use commas, right? So in that last line, you see acetic comma, benzoic comma, and cinnamic acids, a list separated by commas. But if that list is part of another list and too many commas will make it confusing, that's when you might use a semicolon. So 2-butanone, semicolon, sodium benzoate, semicolon, and then acidic, benzoic, and cinnamic acid. So those are the situations where you use a semicolon, right? As though it were a souped up comma. Now, a colon has a different usage, right? But of course, I'm not talking about the mathematical use of a colon, right at the bottom, right? But in the language, a colon is there to introduce something. It could be an entire clause, it could be a phrase, it could be a list of things which somehow describes the sentence that preceded the colon. You have a colon, have a sentence, and you want to say something more about it, you put a colon, right? For example, the example I've given you, 3 reactions are named after Claisen. I'm sorry, I keep picking up examples from organic chemistry, right? 3 reactions are named after Claisen, colon. And then you say what the 3 reactions are, right? The Claisen reaction, the Claisen condensation, and the Claisen rearrangement. Right? So that's when you use the colon. Now, the mistake I have found is that people use a semicolon where they should be using a colon. In this situation where you're using the colon to separate a list of items that describes the first item or something else that describes the first item, people are using semicolons. That's a mistake. Some people also use hyphens, right? This is where you should be using a colon. There are a lot of more elaborate rules in style about the use of other punctuation marks, right? But this is the mistake I have seen in many places, which is why I'm bringing it up today. Okay, my next topic, mass nouns. Another common mistake, okay? There are nouns in the English language, in all languages really, which describe things that cannot be counted. Things that are abstract or things that are present in bulk. These nouns are called mass nouns. They do not take a plural. There's no plural form of a mass noun. And they also do not take, because they are general, that they do not take the indefinite article. They can take a definite article. The word the can be used with a mass noun, but you can't use a or an with a mass noun. Now, what I've shown you here is a list of common mass nouns, and you can go on and on. I mean, just selected these at random. Okay? But the ones that are there in red are ones that show up in papers that I have to edit, which are misused. Okay? So you can give advice, but you can't give advices. Right? There may be evidence for some hypothesis, but there can't be evidences. You can't have evidences any more than you can have dengues or lightnings. Okay? Those are the mass nouns. Can't be counted. Another common mistake is research. You can't have researchers. You can't have a research. I did a research. Wrong English. Okay? So those words don't exist in the English language. There's no such word as researchers or evidencers in the English language. How do you put it then? So an advice can be some advice. It can be a piece of advice if you really want to specify a singular form, right? A research project is okay. Research is a very general thing. A research project is specific. You can have a research project, but you can't have a research, okay? Just use research and evidence if you're tempted to write researchers and evidencers. Okay, some common words where the Americans decided that they didn't like British spelling. The American tendency is to make the word shorter, to use fewer letters. Okay, that's sensible, I suppose. Okay, but you know, the English is a funny language. I grew up personally with British spelling. I spent 18 years of my life in America, so I got used to American spelling, and sometimes I get confused myself. The NSF at least had a policy that they would go with British spelling, but they will adjust that policy if you have special reasons to go with American spelling. So I've listed some of the common words, right, and the differences in spelling. All of you have computers that almost certainly have built-in dictionaries. Remember, the default editor program in Microsoft Word uses American spelling. So if you use British spelling, it will underline it in red or something to tell you that it's wrong. You can switch to the British dictionary, which will do the opposite. Right? But these are some of the common words that I personally have to keep changing when I edit. Okay, so anyway, it's up to you how you want to do it. Okay, so I've spoken to you, I think, for too long already. Let me try and wrap this up. General writing issues. Okay, now I've talked about the specifics, some of the technicalities of language, and there are a lot more that I don't want to talk about. I picked out the examples where I have come across mistakes in the papers that I edit. There are many others. So if anyone here feels like they need a refresher course in style, I'm sure the NSF will be happy to arrange that for you. But now let's go beyond style and talk about your actual writing skills. Okay, so one problem when you're writing something as specific as a research paper is a lack of flow. Think of it as telling a story. When you tell a story, you normally begin at the beginning and logically work your way to the end. Now, there are some authors who will jump around, go back, explain this happened. But in a journal article, you shouldn't do that. You really should not jump from topic to topic in a random way, right? Do it logically so that the whole thing flows. The reader clearly understands what you're trying to say, never gets confused. To further avoid confusion, make sure you use the appropriate language. Now, this is a scientific journal, and you're all working in scientific disciplines, and each discipline has its own set, its own vocabulary, technical language that people working in that discipline generally know. Sometimes some of those words may not be comprehensible to a man on the street. So if you are writing an article for, say, the Daily Mirror or the Sunday Island or something, which was going to a different audience, you would write in more colloquial language or more ordinary language. Okay? That is not appropriate for a scientific journal. You must be technical in your language, but don't be too technical. And I say this because the Journal of the National Science Foundation is not specific to a particular discipline All scientific disciplines are covered. So in principle, there could be people reading your article who are not working in your little corner of science. And this is particularly true, I find, in the newer fields of science, like molecular biology, artificial intelligence, where a lot of highly technical words and particularly highly technical abbreviations, acronyms have crept in, which as a chemist, I'm clueless about. I can't understand what's being said sometimes, even though I have to edit the language. And so you want to keep that in mind also. And sometimes if you're using some words that only people in your specific area of your discipline will understand, just put in a definition. If you're using an abbreviation, the first time you use it, spell out what it is. After that, you can go on using it. Avoid repeating yourself, okay? If the same sentence appears in the abstract, in the introduction, in the discussion, and in the conclusions, you're lacking in imagination. Something is wrong somewhere. Okay, there's no need. You read the sentence once, we understand it. There's no need to say it again. Right? So abbreviate it, put in a different way, summarize it, do something, make it as easy as possible. Be concise. Don't have a long, rambling paper. Right? What does conciseness mean? There's a sentence here. I'm not going to read it out. Right? I actually wrote this sentence, but I took it from a book written by James Lovelock called Novacine. It's a very interesting book. Right? He wrote this sentence as several sentences, but I found that you can actually combine it and make it into one sentence. This is an example of how not to do it. Never write a sentence that goes on for 8 lines. Right? Somewhere along the way, you yourself will get confused about what's the subject of the sentence and what's the verb. And your grammar will be affected. Okay? So just write, don't write all simple sentences, but make sure your sentences don't get too long and are not unnecessarily wordy. Right? So there are some phrases that you can simply avoid. Right? There's no need to say, as already stated. The reader knows that. Right? It has long been known that. It is interesting to note that. These are phrases that maybe in some situations might make your paper more interesting, but in most situations, just clutter it up with extra words. Right? So instead of saying, it is a procedure that is often used, you can simply say this procedure is often used. Makes it a little bit shorter. If you do this consistently, you can probably knock several hundred words out of your paper and make it simpler for people to read and understand. Right? There are many situations where you can use a single word instead of an entire phrase. Okay, so I'm not going to read out the whole list. I'm sure a copy of this presentation will be made available to those of you who want it by the NSF. But, you know, you want to say a small number of, why not just say a few? Okay. At the present time means the same thing as now. Reported in the literature can be just reported. Where else would it be reported but in the literature? You don't have to mention the literature, it's understood. Okay? In the near future means soon. Okay, so there are several situations like this where you can use a single word and get across the same meaning without cluttering up your paper with unnecessary language. Right? So those are broader issues of writing, nothing to do with grammar, but so with that, I want to conclude. It's already almost 11. To conclude my talk. Thank you all for listening. And I believe there will be a session for questions, answers, and discussions later. So anything you want to ask me, I'll be happy to to answer. Thank you all very much.
Yeah, if I want to like write on it, I can still do it, right? Yeah. Which one is the PDF, the third one. Yeah, no, PDF. Yeah, it's better to go. Yeah. Okay, sure.
Thank you, sir, for that informative session. We now move on to a session by Dr. Chathuri Jayasinghe, Senior Lecturer, Department of Statistics, University of Sri Jayawardenepura, on telling your statistical story, what and how to present in research papers. Please welcome Dr. Chathuri Jayasinghe. Over to you, madam.
Thank you for that introduction. So I'm Chathuri from USJ. So this is my topic, telling your statistical story, what and how to present in research papers. So why is it so important to get this right, to tell your story right, to tell your statistical story right? Why is it so important? I can give you several reasons why that is the case.
You have to scroll down.
Okay. Okay, sorry about that technical issue. So I can give you several reasons why that is important. Firstly, if you do a good piece of research, and if you do not present your statistical story right in your paper, then it's obvious that the audience that is reading your paper will undermine your research, right? It's reasonable, isn't it? Because they only have that in their hand to evaluate your research, right? So that's how important it is. Secondly, when you submit your paper, regardless of the journal, if it's a peer-reviewed journal, it will go through a peer review process, right? So in some journals, 2 reviewers will evaluate. In some 3, maybe in some there could be even 7, right? So anyway, it will go through a peer review process, and they are going through your paper, right? So the conclusions have been derived based on statistical methods. So if you do not present it well, they will have doubts, right? They will have doubts about how you have conducted the study. So some researchers may even, finding it a bit too confusing, and they will straight away reject your paper, right? Some may give you a second chance, right? But it's possible that it will get rejected, right? So it's all because how you have presented your story, right? So that is why you need to have it right in your paper in a proper manner. Thirdly, Suppose that your paper gets accepted. And now the journal will have an audience for your paper, right? So they are reading it. Now, still, even if it's accepted, there could be issues in the writing, right? It depends on the journal as well, but then that could be the case. Like you may have got lucky and you have got over that peer review process and it's now accepted. And now you have an audience for your paper and they are reading your paper, right? And your peers could be reading it, your students could be reading it. So still, if you haven't written your story correctly, then there's an issue with the credibility, your credibility, right? So that is also very important. So regardless of whether it gets accepted or rejected, whatever, you have to have your story in a correct manner in your paper. And you may know that reproducibility is a quality of good research. Reproducibility. How can you achieve reproducibility? Through transparency. What do you mean by transparency? How can you make your research transparent? How can you make it that? By writing your story in a transparent manner, right? So, so therefore, when you outline your statistical story, if you write it in a transparent manner, then it becomes reproducible, right? So why is it important to be able to reproduce your research? Because your conclusions are based on a single sample. Even though you have taken it using proper methods, using proper sampling methods from a well-defined population, even though that is the case, now following the methods that you have outlined in your journal, in your paper, another person should be able to reproduce it following the methods that you have outlined, right? So that transparency is required in a paper, right? So it's not that they should get the exact same values. They should be similar, right? So if you haven't outlined all the steps in a proper manner, that is not possible, isn't it? Right? So that is why it's very important to get your statistical story right in your paper. So therefore, you at the end of this session, you'll be able to get an understanding on these key outcomes. So first of all, what statistical content should belong in a paper, and how to write clear, transparent methods and results section in your paper. You haven't shared. The second. Yeah. You had to choose the second one, I think. Okay, yeah. So these are the key points that you'll be able to learn at the end of this session. And you will also learn how to present your tables and figures effectively in the results section. And finally, how to avoid common reporting mistakes relevant to the statistical component. Okay, so now think about this. Where statistics live in your paper? Where does it live? First and foremost, in the abstract, in a very concise manner, right? We have a couple of sentences in there to describe the materials and then the methods that are used in the analysis, and then a few sentences depending on how the space is, how we are going with the space, the results that you have obtained from the analysis, and finally maybe one sentence to say the outcome, right? So final outcome, right? Now, if I go through in detail, we have these sections in a paper, right? So materials and methods section. So what do we have in there? We will talk about the data that we have used in the research, and why that selection has been done. Also, with justifications, always you have to outline. So, for example, if you have picked a certain data set from a secondary data source, and you have restricted the period, right? So you have to always say why that period, why not, why you haven't considered some other period, right? If you had omitted some data, why that is the case. So all these justifications are what reviewers are looking for, right? So when you have them in there, they will not have that doubt at the end. So it will be easier for them to make the final decision regarding your work. And also the methods of analysis. So after talking about the data, you have to also talk about the methods of analysis. So when you are, preparing that section, so it's common to outline them. Like, for example, if you have several objectives, you can have several subsections to talk about those methods specifically, right, under each objective. So when you do that, there are lots of methods available, right? So you have to again tell why that method has been used, not some other, right? For example, if you are using a particular statistical test, why that test? Why not something else? For example, we have two broad groups of statistical hypothesis tests as parametric and non-parametric, right? So why if you are using parametric ones, why you are using parametric ones? Those justifications should be given, right? As well as with each and every method, there could be assumptions. Where, for example, when you are fitting a model, there could be assumptions that it's based on, right? So you have to check those as well. So you have to, in the methods section, you have to tell that you are checking them, that you have checked them, right? Or these are the methods that you are going to use to check them, right? So those things should be mentioned. We are still in the materials and methods section. Afterwards, we come to the results section where we now, go through the results that you have obtained using the data that you have specified, using the methods that you have specified in the material and methods section, right? And then after presenting your results, again, when you are presenting your results, you can go by, it depends on the project, but if you have multiple objectives, you can, even summarize it considering those objectives. Objective-wise, you can present. And then now this part is also important, discussion. where it discusses what it means, what you have found, right? What it really means. There you can refer to literature. And it's possible that when you are referring to literature, some of the results that you have, found are contradictory. So are you going to not talk about them? You have to talk about them, right? So it could be something that's specific for the population that you have considered, right? So it's a new development. It could be, right? So it's okay to present those contradictory results as well. And also when you discuss them, you can also logically think and tell why that could be happening, right? So, this discussion section is also very important, therefore. Now, there should be a link between these two sections, right? There should be a link when you are, there should be a flow. When you are writing it, there should be a flow. So, as I said, if you are doing it objective-wise, the materials and methods section, when you are discussing the methods, the same should follow in the results section, and it can even go into the discussion session as well, right? Section as well. Okay, now if I go through in detail, the things that we should discuss under materials and methods section. So firstly, when you talk about the data, you have to tell whether the source is primary or secondary, right? So if you had collected your own data, then it's primary. Otherwise, it's secondary, right? So sometimes some authors forget to, when they are using secondary data, they forget to mention the source, right? So always mention it. It adds value to your research, right? It adds value, right? So, considering the fact that, provide the fact that it is a good source, right? So, of course, you don't want to use unreliable data, right? So, so mentioning those things, we are being very clear about what we have done. That clarity is what matters, right? So remember at the beginning I told you, you have to be very clear about what you have done, which is not difficult because it's something that you have done, right? You just have to explain it now in a nice flow, right? And then when you talk about if you are collecting data, that means primary data that you're dealing with, then you have to talk about the study plans, right? You have to specifically mention which study plan that you have utilized in the research. When you talk about study plans, you have two broad groups as experimental and observational, right? So if you have adopted an experimental type, then that means you have done some interference, right? You have done some interference in the normal setting. That is why it becomes an experiment, right? So then if it's an experiment, then you have to think what you have controlled. So if there are variables that you have considered to make it an experiment in an unbiased manner, then you have to also talk about what variables that you have considered, right? And also, if it's an observational study, there are various types, right? So in an observational study, you do not interfere with the normal setting, right? There are three categories actually: cross-sectional, cohort, or it's also called prospective. And the third class is retrospective. It's also known as case control, right? So you have to specify which design that you have used with justifications. You have to always justify, and you will easily find justifications. It could be the time and cost, right? It could be time and cost. And, you know, some experiments, some studies, it's difficult for you to do it in a prospective manner because it will take a very long time, right? So in which case you go to retrospective. Maybe I should also talk about these study designs. Maybe I should in detail. So what is a cross-sectional study? How do you conduct a cross-sectional study? It's a survey type, right? So you just select a sample, a representative sample from the population that you have defined using a proper sampling technique. And you have that sample coming from the population, and that will give you information regarding one particular point in time of that population, right? So it's a survey, therefore, right? So if you had done, it depends on the selection of the study design, depends on the objective, right? If it's the intention, if the intention is to just check the association between variables, then of course, cross-sectional study is suited. However, if you want to check the effect of one variable on the other, then you have to either go with the cohort or retrospective, right? So like that. That is why you need to properly outline depending on how you have written your objective, you have to write down with justifications, this is the study design that I have selected, right? So when you are, now you shouldn't stop from there. It's not that you just have to mention that I have conducted a cross-sectional study. That's not just that. You have to also mention the inclusion and exclusion criteria that you have set when selecting the participants into your study. That's also important, right? So then only someone else will be able to reproduce your study, reproduce your research. Otherwise, you cannot, right? So if you let that be unknown, they will not be able to reproduce your research, right? So, and the reviewers will also think about those things, whether you have omitted old people, whether you have omitted, patients with other diseases, whether you have omitted pregnant women from your study, right? So like that, it's very easy to be clear, right? Because it's a study that you have done, right? Okay, so also you have to mention or define your population and study frame clearly, and the sample size. So there are lots of formulas available to, compute the sample size, right? But they have like some limitations actually, because the sample size formulas that are available are actually for very simple situations. They can only handle very simple situations. If you are working with a multiple variable situation, then you have to also think about there is a criteria called EPV, events per variable, right? So the guide is that if you have a multiple setting, then you have to at least have 10 to 15 events per variable. Otherwise, when you fit the model, it will not become stable, right? So you have to think about those things as well, right? So the sample size is not really about using a formula to get the sample size and giving that as the justification. And if your study requires, if it's a case control study, for example, you have to also mention how you have selected the controls. Because there are guides there as well, right? So sometimes you can go with matched you can match a case with a control. It could also be that you go with a guide where you are allowing 2 controls per case, right? So with justifications, how do you find justifications? You can refer to literature, right? You can refer to literature or talk with an expert, right? Or then always justification is what is required there, right? Okay, so that's about data. And then we come to details of the data. So the variables. So when you will have a list of variables. So now when you are now if you take some variables, for example, when you take let's say age, it may be that you have collected the exact age, but in the analysis you have categorized it, right? If you had categorized it, then you have to have a proper justification why you went with that categorization, right? So with justifications, you can, you can state those. And if you have missing data, it's possible to have missing data, right? How you have handled them. If it's coming from a secondary source, did you omit them? Why did you omit them? If you haven't omitted them, then what did you do to them, right? Did you impute them? If you have imputed them, which method you used in the imputation, right? So all those things should be stated. So we are actually making things very clear for that person who is going to reproduce your research, right? Okay, so that's about details regarding data and the analysis plan. Again, as I mentioned earlier, you can, talk about it objective-wise, right? If it's suitable for your research. And there, firstly, always we have to understand your sample, right? To understand your sample, what method you use, what analysis can you use. Exploratory data analysis, right? So you are exploring your data, right? You are exploring your data by conducting the exploratory data analysis. And when you are choosing the methods for analysis, you have to consider what? You have to consider the type of the variables, right? The type of the variable, whether it's a quantitative one or a qualitative one. So the method will depend on that, right? The method will depend on that. If it's a qualitative one, how can you, what methods can you use in the EDA? If they are qualitative, then we can use tables, right? If you want to do 2 variables at a time, then cross tabulations, right? And the bar charts, if you want to visualize, right? Pie charts, if it's appropriate, right? So I will tell you why I said appropriate, right? So there should be a reason why you're using one graph, not the other, right? So that's regarding qualitative data. Quantitative data, how do you explore them? What do you mean by exploring them? You can look at the descriptive statistics. That will give you some understanding on what kind of data, the dispersion of the data, and the mean, median, mode. What are they? They are the central tendency measures, right? So when you have a quantitative data set, you are interested in knowing how they are distributed, right? Whether data are symmetrical distributed or whether it's skewed, right, to one side. right? It could be positively skewed or negatively skewed, right? So when if you are using the software, it will give you all the measures possible. But when interpreting, you have to be cautious now, because the measure that you are supposed to use in the interpretation depends on the distribution, whether it's symmetric or skewed, right? So I will also talk about that in a while, right? So you have to be careful there, right? So you have to do the analysis considering the data that's available to you, whether it matters the type, right? So the variable type. And then you go into the advanced analysis that will actually let you find solutions to your objectives, right? So there, what are the techniques can we use? It depends on the objective again, right? So it could be a hypothesis test, right? So as I mentioned earlier, with the hypothesis tests also, you have two broad classes as parametric and non-parametric, right? So if you are going with parametric, why you went with the parametric? Is it appropriate for your data? Right, so those things you have to justify when you are talking about them. And if you had chosen a particular model to fulfill one of your objectives, then you have to also, it's not really about using a software and fitting a model and presenting it in your paper. There are assumptions also. For example, if I tell you the most simplest model, the multiple linear regression model, so there we assume that the response and the variables are linearly related. So they have to be checked. You have to check that. If it's not linear, then you cannot fit it. Then are you just going to discard? No, there are alternatives, right? There are remedies that you can do to make them linear, right? If they are not working, then you should go with another type of a model, right? So all these things should be discussed. And also regarding software, you have to also mention the software that you have used. Now, when you are mentioning it, this is not the way to mention it. You have to cite the software, the version, for example, because that also matters, because newer version may have more tools, right? Otherwise, that person who's going to reproduce your research will not be able to reproduce it. And it is encouraged to use open source software if you do not have the license, right? So what are the examples for open source software? You may have heard about R, right? So that's a good option to go with if you do not have licensed software. And it also gets regularly updated. That's also a good thing, because that means what? The new tools are there, right? So you can use the most recent tools in your analysis, right? Now, what do you think about this? Is it clear enough, this sentence? Logistic regression to assess treatment and recovery adjusted for age/gender. They have used logistic regression, right? So that seems clear, right? But if you just say data were analyzed using SPSS, that's not clear. Here the method is mentioned. What method has been used and to obtain what, right? So you have to be therefore very specific when you are, when this is a bad statement, therefore, right? So avoiding using such. So this is, yeah. Now, when you come to the results section, so I talked about sample size. Now, as I mentioned, for quantitative variables, when you are, describing them, right? We call it describing them. You can use the method of central tendencies. Along with that, you have to also talk about the appropriate measure of dispersion. Right, so if it's the mean that's suitable to represent your quantitative data, then the suitable method of dispersion that you should mention there is the standard deviation or the variance. But that is so if your data are symmetric, right? If they are not symmetric, if they are skewed, that means if they are skewed to one side, then the mean is not suitable to represent your data. What could be the reason? It can be explained simply by looking at the formula that's been used to compute the mean. How do you compute the mean or the average? How do you compute it? You add up all the values and divide by the number of values, right? So if your data are skewed, that means you have very high values or very low values in your data, right? So therefore, the mean will get affected by those, right? So therefore, it's not reasonable to use mean when your data are skewed, right? So in which case you go with the median, right? So simply state the median, but it's not the standard deviation anymore that you should be using as the measure of dispersion. You have to use the interquartile range, right? IQR in short. Either that or you can mention the first quartile and the third quartile, Q1 and Q3, right? So both are fine. Now, when you are analyzing qualitative data, we talked about tables. So are you just going to do a table of counts? Is that enough? You have to mention the percentages as well, right? Because the counts will be true only for your sample, right? So it's not revealing anything more, right? So, and also it's difficult to understand when you are only having counts in the table. So you have to also have percentages. And regarding inferential methods, now we talked about descriptive and why we need to go with inferential methods in statistics in your analysis. Because the descriptive statistics will only describe your data set. It will not infer what you have observed in the sample to the population, which is your ultimate goal, right? So otherwise it's only going to be a case study, right? So then if you are using inferential methods, again, the method that you should be using depends on your objective, right? It depends on your objective. Now, if you are estimating the mean or the median, etc., you can also talk about confidence interval, right? So apart from, so this is coming from the descriptive analysis. But if you want to, for example, suppose that you are estimating the mean cholesterol level of a certain cohort of patients who are aged in between 20 and 30, right? So suppose that you want to estimate it, right? So using your sample, you are estimating, and the estimate is coming from just one sample, right? So it will only give you one particular value. But when you are generalizing it, it's better if you can also give a confidence interval for it, so that you know it's possible that it will deviate within that range, right? So you should also think about those things. Therefore, now in hypothesis tests, right? In hypothesis tests, I hope you have some understanding on hypothesis tests. So you have to now suppose that you want to check or compare, let's say compare two mean values, right? Belonging to two groups, right? So when you are comparing, you look at the data and you select the type of test that you are supposed to use, right? If your data are symmetric, right? If you can check, if you can justify that they are normally distributed, then of course you can go with t-test, right? If you can, if you have a larger sample, of course, you can go with t-test anyway. But however, if your sample size is small, then you have to check whether it's normal, right? If so, then you can go with the t-test. Otherwise, what can you do? There are also non-parametric tests that you can use to serve the same purpose, but there you are not comparing the means, you are comparing the medians, right? So whatever the test that you are using, make sure you go to the theory. It's not that you should understand the construction of it, but you should be able to understand how the hypotheses are written, what is actually being compared. Because you, in the conclusion, you cannot say after conducting a non-parametric test that you have compared means, because it's comparing medians, right? So then the reviewer will think that this person doesn't know, and or it could be that you have applied the correct method, but when you are interpreting, you are making the mistake, right? So so like that, you have to be careful when you are presenting the results as well as interpreting them. And when you are writing the conclusion of a hypothesis test, how are you going to, what are you going to write, first of all? Are you just going to write that your hypothesis, the null hypothesis, got rejected? That's not enough, right? You have to state the p-value, relevant p-value, right? And it's not also enough to state that your p-value was less than 0.05. You have to specify the p-value as well, right? Because it will tell you how strong the data is providing evidence against H naught, right? So therefore, it's important that you specify those values as well when you are presenting your conclusions. Sorry, the results. And another thing that I wanted to point it out is, now suppose that you have done a cross tabulation, and then you want to check the association between the two variables, right? Now, of course, I told you already, association is possible if you had done a cross-sectional study, right? So when you, how do you check the association? Can anyone tell me? You can perform a chi-square test, right? So now how do you present the result of this test? Are you just going to say that we found that there is association? Is that all you're going to say? What else can we present there? We can present the p-value, right? We can present the p-value, or you can also present the test statistic value as well. It will tell you again how much strong evidence it's providing against the rejection or the not rejection, right? So those things will also tell the reviewer that you are very thorough about those things, right? Okay, so it's okay to be thorough, therefore. And also, association is not correlation, right? So that is it's not a cause effect, right? So you have to be careful there as well. And one more thing, when you're performing even the chi-square test, you have to be careful. Why? You should have, there's an assumption there as well. You should have a sufficient sample size, right? Yeah, expected cell count should be greater than 5, right? If not, you cannot perform the chi. And if you have that table in the report, straight away the reviewer will know that this is not right. And yeah, so he or she will have a bad impression on the analysis, right? So an alternative for such cases is to go with the F-test. Sorry, Fisher's exact test, right? So Fisher's exact. So you can go with Fisher's exact when your sample sizes are small. And when you are presenting the results of models, are you going to only present the final model? Is it important to present what you have done prior to achieving the final model? That's also important, right? That it's okay to outline that process as well, but if you have space restrictions, you can omit a lot of details on all the models that you have tried. But in the table, you can mention the details of most important models, right? So let's say that there are also variable selection processes when you're fitting models, right? There is one called backward elimination, right? Forward selection. So like that, again, when you are fitting such a model, you can tell how the variable selection has been done as well, right? And what in a model that you have fitted, what are you going to present? The coefficients of the model, right? Why it's important to present them? Because they will tell you about the magnitude of effect that they are having on the response, right? You cannot omit that, right? Along with, of course, the p-values, right? Whether they are significant or not, maybe you can, mention it with the asterisk, depending on the level of significance of it, right? And all those things. And also I mentioned about assumptions of the model, right? You have to also show evidence that you have checked those. You cannot simply say all the assumptions are satisfied, after discussing the output of the, you have to show the reviewer that you have tried, you have done the checks. Several lines on that is also necessary, right? So if they are violated, then of course there is a solution, right? There's a solution. It's not that you just say it's violated and present there is you cannot do that also, right? So like you have to justify why you went with after that violation, why you did. For example, you can do certain transformations to the model, right? So when you are picking the transformation, why you pick those transformation, not something else. Also, you can talk about those things, right? So that will, when you do that, the report that you will get at the end from the reviewer will be less complex, right? Otherwise, if you get one that's good, right, then you have another chance to improve and resubmit, right? Okay, so, and also now this is a common error that I have seen in papers that have been submitted for evaluation. Now in them, the variables, how they write the variables, you should not be using any coding. The readers should be able to understand what they are, right? So you cannot straight away, for example, I've also seen people taking outputs from straight away from the software and pasting it. That's also not acceptable. You have to create your own tables and present them without copy and pasting outputs from the software. Okay, so again, if I talk about tables and figures, make sure the titles are clear, right? And if you have confidence intervals, that's also fine, right? But if you have multiple series, it's not advisable to add confidence interval because it will look cluttered then, right? Okay, so now I will talk a little bit more about this. Yeah, so also the labels, the axis labels and the scales, the units of measurement. That's also very important. So don't forget those when you are drawing your figures. And also, it's advised to avoid using 3D figures, right? Because when you look at 3D figures, I will show you one example right after this. It's difficult to interpret them. It's for our eyes, it's difficult to make a meaning, right? For example, if I show you this one here, when you compare these two, there's an issue with these two as well. I will ask you what that is in a minute. But if you look at these two, which one is easier to interpret? This is a 3D one, right? It's difficult, like these two seems to be same sized, right? Whereas when you have it in 2D, it clearly shows that there is a difference. Okay, so avoid using 3D if you can. But for some figures, you will have to go with 3D if it's a spatial one, right? Okay, so if I now talk about common errors that authors are using when creating bar charts. Actually, this is the x-axis, it doesn't start at 0. I will show you one example. This one here, if you compare these two, drawing something like this, right? It's exaggerating, right? The difference, right? So avoid such things. And again, you know the purpose of drawing a line graph? It is for time-dependent data, right? Only then you can, so I will show you an example for that also. So something like this. So now here, if you compare these three, which one you think is the best? Is it okay to present it like this, time-dependent data? It's difficult to follow the dots to know how they are like progressing, right? It's difficult. So that is why you need to connect them, right? So again, you can also avoid this legend and have it at the end of each series. It will also help you to understand the figure in a better manner, right? So all these options are available in software. So make use of them. You don't have to go with the default always. Even when you are when you are trying to visualize a distribution, normally you would use a histogram, right? Visualize distribution. So you can also change the we call it the bin width of the bars. With lesser number of bars, it may hide the the changes in the distribution. With more bars, it will become very close to the data, right? But you should not get too close to the data as well. Otherwise, it's gonna look, it will have a lot of fluctuations, right? So then it's difficult to understand what it's trying to tell. But just to let you know that you are able to change those appropriately, so that it will give a better output. Where am I going with the time? Well, okay, 10 minutes more. Right. Yeah. So with the pie chart, so one problem that these are having, now 3D is not appropriate. We concluded that. What other issue is there? So let's say that we went this one. Is that a perfect one? Yes, percentages should be listed. Another one, it's also better if you had ordered the slices considering the size. Then it's easier for our eye to understand, right, what it's trying to tell. Okay, so also avoid using pie charts if you have a lot of categories. That's also meaningless. If you are finding it difficult to understand, there's no point in having such a figure in your report, right? So avoid using such. Okay, so I think I have covered most of the points. So I talked about these things as well. Okay, so if I give you now. Okay, sure, thanks. Right. So if I give you a before submission checklist, now this is relevant to the statistical part only, right? So these are the things that you need to check whether you have included or not in the relevant sections. So you have to mention the data source, the designs, exclusion, inclusion criteria with justifications, right? And also you have to define properly the variables as you have collected it, right? Along with the units. And if you have used any codings, again, justify why those categories have been created in such a manner, right? And also regarding the missing data, that's also very important. If you had ignored them, why you have decided to ignore them, right? If you haven't ignored them, then what methods that you have used to handle them, whether you have used any imputation methods. If you have used any imputation, which method that you have used, again, why that method has been used, and the methods of analysis, tests, hypothesis test, why that test has been used, not the other, and the model also, right? If you have used a multiple linear regression model, or if you had used a logistic regression model, why a logistic has been used, not a multiple linear regression, right? Along with the assumptions and how you check them, and after checking what you, what you concluded, right? Okay, so, right, so at the end, this is the ultimate target. Right, so another person should be able to reproduce your research. Okay, so you have to make sure it's written therefore in a very clear manner. Okay, and also this is very important, acknowledging limitations, right? You should not hide them, right? The limitations that can occur, right? In practice, that can occur, and you should write them. What are the limitations in your study, in your conclusion, in your methods, and the data, right? So limitations are linked to all, right? Everything. So you can discuss those. To avoid them, you can give future recommendations, right? So okay, so now this is a list that I was given by NSF. So I think I covered as most commonly occurring issues in submissions. So I think I covered most of them. Now they are also saying that they have found, as a common issue that when it's possible to conduct an advanced analysis, they have just stopped at a simple one. So how to avoid that? You can, if the literature is not providing you with a advanced method, you can consult a statistician, right? So don't be afraid to consult one. And in most universities, we have such units, right? Consulting units, statistical consulting units, and they are offered free of charge, right? So reach out to them, and they will give you, they will help you with the analysis. And yeah, so don't be afraid to try advanced. It's not about complexity, right? But through an advanced method, you will be able to give the audience of your paper a better conclusion, right? So that's the requirement. Okay, so I think I covered most of the things that are listed here. So closing thought. So good statistical reporting isn't about complexity. It's about clarity and honesty, right? So be honest with what you have done. And everyone is trying to do their best, right? So, so you don't have anything to hide. As researchers, we always try to do our best, right? And thank you for that.
Thank you, madam. Now we'll open the floor for a discussion.
in a like cohort with a rare disorder, can the sample size matters? So how can we approach that in a cross-sectional study or a retrospective analysis?
So you said cross-sectional study, right? So for a cross-sectional study, yeah. So the sample there are formulas that you should use, right? So it matters. The design matters which formula to use. So accordingly, if it's in the formula itself, you need to you have to substitute values from the literature, or if literature is not providing you such, then you sometimes you can go with a pilot and get the estimates. Anyway, at the end, I just want to tell you there are formulas that you can use to compute the the sample sizes. And depending on the study that you have selected. Okay, prevalence. Okay. Yeah. Okay. Then a cross-sectional study is enough. Yeah. So
Does the sample size matter?
yeah, it does. Yeah, because it depends on the size of the population as well, right? When you'll be ending up with a better estimate with a larger sample, of course. But it's not possible to get a very large sample, right? So then you can make use of a formula for that.
And madam, then in the cross-sectional study design, let's say if we collect data from 400 study participants, and for some variables we don't have results for from those 400 participants, maybe it's 300. So then is it okay that that for certain variables we are going with 300 sample size, and for other variables we are going with 400?
No, the missingness, you have to be careful. You have to check whether the missingness is occurring randomly or non-randomly.
So then that we need to like specify the reasons why that the data is missing.
Yeah. No, first of all, check whether the missingness is random. If it's random, then you can use imputation methods or whatever if appropriate. But of course, if 50% or even more is missing from a certain variable, there's no point in having that in
that particular variable.
Yeah, you will have to omit, yes.
Okay, thank you.
Any more questions?
Any questions for me?
So I'm a postgraduate researcher and I'm doing my MPhil. So I would like to know that, our supervisors, like, they give us studies to conduct. And for example, I'm working on cyanobacteria. So we had to do some screening tests and we had to do a lot of tests, they say, to find out what are the certain properties of this organism in particular. So my struggle is that whatever research I do, at the end of the day, I should be able to publish it. So if I am going to like do just a screening study, then my chances of getting published are going to be a little bit odd rather than publishing it with a problem-solving mindset. Like, for example, the previous professor who came before you said that we can't publish oxidation state because there should be enough novelty in it. So how can we kind of like communicate between our supervisors or whatever to go towards a direction where we can publish it?
Okay. That's not an easy question to answer. You may not like my answer. Right? As Professor Abeysekara was indicating, the NSF journal has certain objectives. There are other journals, right? So what you should do is, on the one hand, you want to relate your work to something broader, where you with other authors, not just yourself, but your supervisor and maybe other co-workers, will eventually aim at publishing one or two really big papers which summarize all this. But meanwhile, you're doing some work which may end after a while. And what you're basically saying is that work won't allow you to publish a paper in the Journal of the NSF. Right? So for that, you might have to find a different journal. Right? There are also many different kinds of papers that can be published. There are what we call full papers. Then there are communications, which are like preliminary. I don't know whether the NSF journal accepts communications. Okay, so as a communication, you can publish preliminary stuff, making it quite clear that your work is still in progress, but there's some data that you have gathered, and you have a final objective which will be reached eventually. So those are some of your options. Okay, but ultimately, if your aim is to have one massive paper where you and your supervisor are the only authors, it may not work. Modern science is done in large groups. Right? There are papers in particle physics, absolute cutting-edge, state-of-the-art science done by the organization in Switzerland, which gets physicists from everywhere in the world, including Sri Lanka. And their typical papers are 50+ authors. Right? And they're just discovering the most recent particles, which are, mind-boggling science. And even in many disciplines, you find teams of 6-7 authors from different fields contributing to a paper. So really important papers are very seldom done by 2 authors. Don't expect, I mean, if you can, it's wonderful. If you and your supervisor can publish one fantastic paper, that's wonderful. But don't expect it to happen. Right? Focus on being part of a group that's going to publish something big.
Thank you, sir.
Any other questions for me?
Am I audible?
Yes.
Okay, when we are hoping to
Let's say
publish a
per
review
journal is
paper,
open for the
what
qualitative,
are the concerns that we should
qualitative
focus on?
research work, like market survey, customer survey analysis, and doing some work with this designing part of things? Is it open for these type of sections?
That question, of course, you have to address to the staff of the journal. But I have seen all kinds of papers. I mean, the ones that have been given to me to edit, just to edit the language, have covered the whole range from highly quantitative studies, modeling studies, experimental work.
Qualitative also.
Qualitative also, yes. Not all the journal articles published are based on quantitation. Right? A lot of qualitative work have been published. Some fields of science are qualitative in nature, observational, like field biology, for example. So and even organic chemistry, to a great extent, is qualitative. So don't assume that you have to have the kind of data that the previous speaker spoke about, where everything has to be statistically analyzed. That's not necessary. You have any comments? Answer your question?
That means we are doing some researches regarding designing point of views, then design collection designing based on the customer survey likes. So we have to know that the opportunity is there for this type of papers as well.
I think what you should concentrate on, without seeing your work, I can't comment, and certainly I'm not the person who takes decisions as to whether something is going to be published or not. By the time papers come to me, they have been accepted. Some of the criteria were the ones that Professor Ajita Besekar spoke about. Things like originality, novelty, significance, right, to show that it's important. As long as those criteria are met, I would think in any area of science, qualitative or quantitative, you can reasonably expect to be published.
We can try.
Yeah.
Thank you.
Anyone else? I mean, it doesn't have to be just questions and answers. We can also have a genuine discussion where members of the audience are free to express their views. If you have any comments, you can do that also.
Sir, this is actually not a question, but a request. After hearing at your lecture, I understood the several mistakes that I have done in my past experience as well, which obviously the editors or reviewers have corrected. Some of this simply have been overlooked by me and of course the author panel as well. So I'm asking requesting whether you could hold another session, maybe even a short one, just going through the language stuff that you were talking about. I think many of us will benefit from that, and if NSF can.
It can be done. I have done such things, both for, I remember conducting a 2-day workshop on scientific writing for the scientists at Slintech when I was there, in collaboration with someone from the University of Colombo English Language Teaching Department. And more recently, I was a resource person in a 1-day workshop at the ITI. And so it depends on where you want to start, the very basics, or today I was pointing out mistakes, but I didn't cover the underlying basics. There's no time. We have 1 hour talk, right? To do, I mean, I have a series of presentations I can give. And by the way, I mean, I don't claim to be a professional teacher of English. I'm a chemist. But I do cover things that are important in English writing. So on grammar, on punctuation, the correct use of certain words, and other issues that may be relevant. Even on the I talked a lot about figures, significant figures, and how you present your numerical data and stuff like that. So yes, I can do it, but someone has to organize it. So your request must come to the NSF, and they will see what kind of a demand there is, whether there may be 6 people who want it, or there may be, 60 people who want it. And then based on that, we can certainly do something. Yes.
Thank you very much.
Everybody waiting for lunch, right? So if there are no other comments or questions, I'll turn this over to the organizer.
If you have any more questions, you can put it forward. I think this is a good time to you to have lively discussion with our eminent resource person. So I think because like nearly 80 here, maybe 80 questions. Seems not, so we can break up for lunch then. Baggage can give other messages.
Okay, we have an online question.
Yeah.
I think you can ask the Subhagya, you can ask the question or type it.
Okay, so sir, when we are hoping to write a review article, so what are the things that we should mainly focus on?
It's not clear. Can you ask it loudly?
So when we are hoping to write a review paper, review article, what are the concerns that we should mainly focus on?
What's your policy on review papers?
Yeah.
Yeah, actually, NSF review articles, we expect a very critical review of particular field, where we look at your experience, your publication experience, and also the content. So it should be a critical comparison review of whatever the field you are planning to write. It's not just a survey. Yeah, it's not a literature survey. And actually, we have given guidelines in our website related to review articles. Do you still have any doubts about it?
No, madam, thank you very much. I have another concern.
Yeah.
So I think, am I audible? Am I clear?
Yeah, but it's still better if you can speak little bit louder.
Okay, madam, let's say we have to actually add some novelty to our research paper when we are writing, when we are conducting a research. So, what are the ways that we can add this novelty to our research? Whether it should be a theoretical development or some novelty in application, and especially when we are conducting a PhD, so we have to add that novelty. So, can you explain how we are going to do that?
Actually, Dr. Gunaratna can explain it
I'll
much
try
better.
to answer the question. Anything, I mean, all the things that you listed would work, or any of them would work, provided that you can convince the editors that your work is important. Okay, so the novelty shouldn't be for the sake of novelty, but it should be for the sake of doing something that is significant in the area of science, whatever your area may be, right? So that you can show that your work is going to be important and relevant. It could be a new method, completely new technique for doing something. It could be a new idea that you have for developing a new product that might be commercializable. Okay, so there should be something to make it important. Does that
Thank you.
answer your question?
Yes, sir. Thank you very much. It was actually very fine and very detailed presentation. Thank you very much for providing us that.
You're welcome.
Is there anyone online you want to raise more questions? So we can just stop this session now. So we would like to invite you for lunch. So it's being served outside. So you can be here back by 1:30 p.m. So please be on time so we can go. Yeah, then can you be here by 1:20? We appreciate your time management. Thank you.
Our next session. That's all, it's not disturbing. Our session, that's okay. Our next session will be delivered by Professor Roshan Ragel, a professor
Recording in
in computer
progress.
engineering at University of Peradeniya, director of the Staff Development Center, deputy director at the Multidisciplinary AI Research Center, and CEO of the Lanka Education and Research Network. Today, he will share practical ways to use AI tools in article writing and key ethical considerations authors should keep in mind. Over to you, sir.
So that's right after lunch. Good afternoon, everyone. Thank you for giving me this chance, and thank you for coming on time after lunch. Let's start. We'll start with a small video clip on AI. And then from there, we'll discuss how we can use AI to ethically use to write articles.
I am a visionary. Illuminating galaxies to witness the birth of stars. And sharpening our understanding of extreme weather events. I am a helper, guiding the blind through a crowded world.
I was thinking about running to the store.
And giving voice to those who cannot speak.
Do not make me laugh.
I am a transformer, harnessing gravity to store renewable power. And paving the way towards unlimited clean energy for us all. I am a trainer, teaching robots to assist, to watch out for danger, and help save lives. I am a healer, providing a new generation of cures and new levels of patient care.
Doctor, that I am allergic to penicillin. Is it still okay to take the medications?
Definitely. These antibiotics don't contain penicillin, so it's perfectly safe for you to take them.
I am a navigator, generating virtual scenarios to let us safely explore the real world and understand every decision. I even helped write the script. breathe life into the words en muchos idiomas y escribí la música. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
We are going too dark with AI. Right. So, somewhere sorry. As you so might be echoing because of the sound. Okay, some technical challenges. Right. So like you saw, the video is talking about AI. In fact, like the video is sort of AI introducing itself, what AI can do and the different type of thing it can do. In fact, when it's the whole video, if you look at its music, it is composed by an AI tool called Aiva, right? And there are a lot of other AI tools that can do different things. For instance, you saw the self-driving cars using AI, or somewhere in a diagnostic for on a tab, some AI tools doing something else like medical related and so on. So hopefully they can help in all these different places. But remember one thing, right? So all of these AI tools are specifically designed and trained for those specific tasks, right? Now you get an AI tool, all of you have access to something like ChatGPT or Gemini. They are not these specific tools, right? And I'm sure you have already experienced how dumb they are, and right, how challenging it is to use them for everything, right? So these tools are very different. There are so many different such tools. And the whole idea of having a discussion like this on a specific topic, right? So we are talking about writing, or we can take a step further and say research, right? So research involves writing, research involves few other things together, like put together, right? So when you want to do this, the generic tools can support, but to some extent, only to a limited extent, right? So we are going to discuss how we can use specific tools designed for these research purposes, writing work and whatnot, and how we can use these tools. And I'm sure as researchers, you will have enough and more questions about the ethical use of these tools. Can we use them? What do publishers say? What will the editors say? What will the reviewers say? What will my supervisors say? All sort of questions. I don't have direct answers to them in my slides, but I thought I'll take them as questions at the end, right? So I'll give time for you to ask questions where I'll take them one by one. Although I'll highlight a few things while I'm going. So I'm focusing more on how we can use these tools here, right? So not about the other aspects and the policies and the perspectives of different part of stakeholders of a research process. So in the next 40 minutes or so, I'll be quickly covering these topics. I'll do a quick intro to what artificial intelligence is. And then I'll talk about how AI can be used in research and focus more on writing, but other research things as well. Like, for example, if you want to do some statistical analysis, we were talking about statistics earlier. So there are tools to do those, right? So, and then I'll talk about some challenges, even concerns that you all have. What can we do about it is under consideration, and then I'll conclude. So just to quickly start, artificial intelligence, in fact, is a large area As you can see from the Venn diagram, it's a bigger circle inside which we also have new emerging other areas coming in. Artificial intelligence generally means can a non-being like a machine have intelligence, right? So when we wanted to, and also when we started talking about artificial intelligence, we were thinking the benchmark is human intelligence, right? So I said, I'll repeat, when we started talking about artificial intelligence, we thought the benchmark is human intelligence, right? Not anymore, right? So, therefore it's artificial. We are the real intelligence, and what we have is the real intelligence, and then machines, they have artificial. The artificial intelligence have gone through several phases. The recent one being what is known as this machine learning. The idea of machine learning is we don't go and program the machine to be intelligent, but we program the machine to be like how we learn. So we learn, make the programs or computers to know how to learn, right? So that's the difference. So we are no longer writing programs to make it intelligent, but making a program computers in a way so that they can learn. So how do they learn? They learn by using data. So whatever the input that is coming from all sort of different modes, it could be listening to somebody, it could be someone typing something, it could be looking at some videos, it could be getting something through a sensor, for example, the temperature of this room, right? All these are data, different type. So they all can go in, and the data, when a machine gets all this data, can it learn from the data? That's the idea of machine learning. We have done more. Machine learning has gone into what is known as deep learning, which is with more detailed type of learning, like how we learn in brain. I'll not go further. And then with all this development, we have gone into an area called generative AI, artificial intelligence, that not just learn and figure out what's going in the world, but it can also generate new things. Same way how we do. Like when let's say we if we can write a story, I can write a story. How do I know how to write a story? How do I write a story if I'm writing a story, right? A story, when I say story, I'm talking about like a creative writing, a story creatively written, right? So to write a story, I would have learned a lot of different things in sort of different places. I would have learned how to write, I would have learned a language, I would have learned how to think creatively. I would have done it in a lot of different places, putting all together. Now I am writing a story. The story I write, if I have not copied it from anybody else, although I learned all that is needed for this story through a lot of different means, now what I am writing is novel. It's my own. I have the copyright. I write it. Nobody else has written the same story the same way. Maybe there are ideas coming from so many places. It's my story. So now the machines can do something very similar. Machines can do something very similar, not copying from other places. It learns from other places the same way how we learn from other places, and can generate things. Generate text, generate video, generate audio, can generate all these different things the same way how we can do, how people can do. So that is where we are now. And that I spent some time to explain this because it has a lot to do with how we are going to judge what this generated AI things are. The judgment is going to come in, right? So because that is the concern all of us have, right? So yeah, so that's the generative AI part of it. And on top of all this machine learning intelligence coming in, because we started making these machines to learn from data, there is also another field, as you can see, that is cropping out, which is called data science, which is about how do we manage data. Now that we are talking about data, how do we manage it? If we have larger amount, we have to keep them. How do we manage the different type of media, like if it is videos, if it is text, if it is different types, how do we manage them? That's another field. And also based on that field, there's also things like, can we get some information out of the data? Can we make some trends out of the data analytics, all those different other field has come out, right? So that's just like a AI, machine learning, data science 101. going forward, we are going to just focus mostly on generative AI that can generate things. That is what we are going to learn how to use ethically for writing. So AI, as you know, I'm sure all of you have used the now called AI tools, right? So any AI, one of these AI tools, starting from tools like ChatGPT. As you might know, a tool like ChatGPT, when it was released 3 years ago, it became so popular so fast, very fast. How fast is, how many of you know there is a tool called Facebook? Why I'm asking is the younger generation, they don't know. Just in case. Younger generation, they don't use Facebook. Facebook is an older generation, like our generation time, right? So now you use Instagram, right? Or TikTok, right? So these are the new tools. So why I'm talking about, so the Facebook took about 1 year to reach 1 million users. Instagram took about 2.5 months, 75 days to reach 1 million users. Guess how many days ChatGPT took? Or how many months? It took 5 days. 5, right? So in 5 days, it's reached 1 million users. Now it is used monthly about, the last number I checked, somewhere like 750 million users, right? Are using it day to day, or not every day, but maybe in a week if you aggregate, right? So that's the usage. So much popularity. So these tools can generate text. They can generate all sort of different things. They can generate video, audio, as you might know, images, and so on. And you might also would have tried generating these things using these tools, and you would have realized they are useless, right? So what I'm trying to say is the same tool might not do all of this well. Different tools can do different things well, right? So they are separately trained. If you want to have a tool to generate images, a specific tool can do. That also depends on what you want to generate. Let's say you want to generate some lab related setup. You can have a specific tool that is trained on such things, and it can generate those better than some like something else, right? So something else like seminars, right? So you can have specific tool can do better. So there are a lot of different tools to do these things. I mentioned that AI became popular recently, but as a timeline or a history, AI has been there, the idea has been there for, as you can see, from 1942. The term artificial intelligence was coined in late 1950s. Earlier, they were calling it some intelligence. Machine intelligence is the first term that was used. And as you might know, like the scientist or the mathematician, the name of Alan Turing, when he was building a machine to break this Enigma code. Enigma is a machine that encrypt or like made the communication in the Nazi army secret, right? So the army wanted to communicate. So they send communication between two places, and the good army, the British army, that is, right? So the British and American. So they were trying to intercept, and they did intercept messages, but they are unable to figure out what's going on, because the one who do the transmission was using some sort of encoding, right? Some sort of cryptic, like, so they change it in some way and they reverse it on the other side using some, if you know how it is done, using some secret. So they don't know the secret and they can't do it. So they put a few scientists to build a machine to break this secret. And they did. Like, in fact, 1942, Alan Turing and his team, they built a machine to break this secret. While they are building, Alan Turing actually and his team figured, it looks like these machines one day, not on that day, one day can be smart, can be intelligent like people. Right? So they spend time and they realize, okay, we can build these machines to like break code. They can do things faster than us, and therefore they can break code. And can they also be more smart and like us? Right? That is the whole starting point of something like the idea of machines or systems, computers having some intelligence. Since then, a lot has been done. This timeline stops at 2020. ChatGPT and others has come after this. So during this timeline, some important interesting things happen. For instance, one of the things that happened in the later part of 2010, actually 2017, is related to machine learning. And the ultimate impact of it is on the next slide, right? So this, I hope you know, last year's Nobel Prize for Chemistry was won by a team. Usually Nobel Prizes for chemistry would have been won by chemists, but those who are working in chemistry. So last year it was won by two people who are working, like a protein structure prediction was done by two chemists, but one of the other people who won the Nobel Prize is a computer scientist, right? So why it was given to the computer scientist is the one who built this AI system that can do what is known as protein folding. So protein folding is to find from the protein sequences to find the protein structure, the 3D structure, right? Apparently, I was told, right? I'm not an expert in this. I was told the PhD students who spend time folding proteins, by the time this was happening, this is 2020, somewhere around 2020, the PhD students who do this work, they spend about 1 PhD time to fold one protein. Right? One protein sequence to fold it to find the structure. It takes 1 PhD time, 3-4 years, right? So this system has folded all 1 million protein that are out there within a year, right? So no more 1 million PhDs, right? So that's what it has done. For that, they got, I mean, not for that, obviously, but got a Nobel Prize, right? So that's for the chemistry prize. And this tool is for actually the original tool, and the fund and all that are coming from Google. Google is the one funding this project. And in fact, like originally when this project started, it was a separate company. Google bought the company and now Google is funding it. Recently, with all these generative AI updates, Google is building what is known as Alpha Earth. This is AlphaFold. Another tool called Alpha Earth. They are going to release it soon. It's a tool where the AI looks at all different parameters that we are collecting: temperature, satellite images, the GPS location, the Google map, all that to put together in a single system. A system that looks at Earth in a very different way because it has so much of different information coming in. That is the tool they are building. We don't know what will happen with the tool, but that is the type of things that are happening, just to give you some insight. So this sort of individual tools are doing really well. Here is an example. So this is a report coming from Stanford. The report is called AI Index Report. The AI Index Report has a portion where it compares AI systems performance with, if you look at the top line, human performance 100%. So it compares against human performance, how these tools can do, how well they can do. So you can just look at something like, for example, the yellow color one, medium level reading comprehension. You can see it's above the human. So it can read and comprehend. These tools can read. A specific tool can read and comprehend better than human. That's what that line means. One other interesting one is the blue one, PhD level science questions, right? So apparently, again, they have build a tool, run it through the test, benchmark, take PhD level questions that are released and give it to the tool, and tool apparently is doing better. Again, the blue line, if you can see, it's about 100%. So these tools individually, we have shown that it's possible for these tools to be trained and pass benchmarks. That's all it can do, right? So not anything more, not anything less, right? So they can be trained to do specific tasks and do really well, better than how us in average human can do, right? So that's what it means. So just to give you a little more into this sort of tools and how they can build, just another small device, I wanted to just show a quick video clip.
What we experience, what we smell.
Can I eat this?
Yes, dragon fruits are low in sugar.
What we hear.
Hey, what should I get here?
点什么呢？
哇，这会是中。
What we see
Oh, capture this.
and what we feel. What if we build more memories,
What are some fun things to do nearby?
share more moments,
Play songs from the last time we were here.
What would happen if we rediscover our senses? What if devices weren't the experience?
Catch me up.
Lucy called and your flight is at 7 a.m.
Tell Lucy I'm on my way.
What if life was?
AI pin.
So that's just an advertisement for a small device, the one that is worn there by the man. And it's a small device that is supposed to be a replacement for a mobile phone and more, right? So it can, you can see, you can talk through it, and you also, it's connected to a engine like ChatGPT. Actually, it's connected to ChatGPT type of an engine. And then you can like project and use it like a phone. You can dial things, you can talk, it can translate and various other things. A tool like this. So it's up to our imagination how we can use this sort of technology to build new things, right? So that's what I just wanted to show there. So let's move on to what we wanted to discuss really, which is about how we can use this sort of a technology in research, right? I'm going to go through a large amount of different things that we can do. One, don't get overwhelmed, right? I'm warning. So the idea is not for you to understand how you can use all of this and how, like the how part, right? So hands-on how you can do, you need a little more time. I don't have that amount of time, right? So the same thing can be done like in a day, right? So here the idea is to show you the possibilities. The different possibilities, like if you want to write, these are the things you can do. If you want to do literature review, these are the things you can do. So I'm going to quickly go through a number of different tools and techniques and the possibilities, right? That is what you are going to see next, right? Ready. So when you take research, I'm putting them into these 4 quadrants. A, research conception and execution. Right, so in fact, like this, as you can see, is coming from Cornell, the diagram. Research, conception, and execution. Next, which is like most of what is happening in a lab, right? So coming up with an idea, coming up with a proposal. While you are doing it, you'll also have to obviously do what is known as like a proper literature review. All that are part of it, and then executing the research, doing the research itself. And then B is dissemination. So which is what we are focusing mostly here, writing, presenting it in some form or the other, right? So that's dissemination. And then obviously the research cycle will also have things like translation it into a commercial venture or any other form. And then from there you go into the next phase where you'll be earning money and you'll putting the research fund back, and it goes in a cycle. Right. So AI tools, there are tools that can be used in all 4 of these quadrants, right? Anything that you do in any of these quadrants, there are tools to use. So, but I'm going to more focus, anyway, the workshop is mostly focusing on B. So I'll be mostly focusing on B, but also I'll highlight a few things that are connected, overlaps, right? For example, if you take proposals writing, it could be dissemination, but it could also be research conceptualizing, right? So it's about writing. So we can, so A and B is what I'll focus on. So before I go there, here is some statistics from a paper. That's a journal, PLOS One journal paper published, I think early this year. Early this year. The study is from last year. The study was done actually by OpenAI, the company who runs ChatGPT. So what the study did is they looked at 23,200 plus students in 109 countries. And they have asked the students where they are using their ChatGPT tool, where it is used, right? And the places where it is used are listed in the bar chart. And also you have on the same chart another number with an X. That is the student perception on how fast they can do the work using the tool. How fast, the productivity improvement, right? That is their perception, right? So there's no other measure, it's just a perception, right? So you can see the very top things are like brainstorming, summarizing, research assistance, academic writing, study assistance, translating, personal assistant, coding, proofreading, calculating help. Apparently they are using it as a calculator. I hope you know we use like even search engine as a calculator, so why not an AI, right? So professional writing, creative writing, this is the order. And you also can see the time, so the largest being about 30%. So it's about 10,000 plus students are using it for brainstorming out of the 23,000 and so on, right? That's the number. And also the improvement in terms of acceleration, you can see the numbers are between like almost 2 and 3, right? So there's few numbers which are below 2. Creative writing, for example, it's 1.9. So it's about 2 times, right? I hope you understand what this number means, right? So if you want to do some creative writing, some imaginary thing, a 1-page or a 2-page document or even 10-page document, one of these tools can generate it in no time. So the acceleration can be 100 times. Why is it 2? Is because, why is it 2? Why is it not 100? Why these numbers are 2, right? Writing activity, you know these tools, you give a topic, creative writing, it can write a book in a few minutes, right? So the acceleration or the productivity improvement should be several times, right? Why is it just 2 times or 3 times? Any idea? Why is it 2 times? So why is it 2 times? Is because people involved, human involved there, right? You are not letting the tool to write and finish it, right? You are using the tool, but you are checking, you are verifying, you are improving, you are updating. So you are involved, people are involved. The message there is people are involved in the process. That is why it's still slow. Why are we involved? Not to make it slow. Why are we involved? To make it proper, make it right, right? So people had to be involved in the process. Remember that, right? So it's just 2 times, not like 100 times. Don't expect a report to be written overnight, right? In 2 hours when it is expected 2-3 days or 1 week. That expectation is, yes, it can generate things. But whether it is right or wrong, we need to spend that time, right? That's important. I just wanted to highlight that part. Right, so let's move on to how we can use this tool or the AI in these different places. I'm going to highlight a few examples. One, I'll start from literature review. It's not specifically about writing, but literature review has like going through papers, figuring these things out, and then putting it together. I see a lot of you are taking photos. Maybe I can share the slides. You have a way of sharing slides with them. Yeah, we'll share the slides. Come down and sit and listen. Yeah, so much cameras. The ChatGPT is the celebrity, right? So, right. So, for literature review, there are specific tools designed just to do literature review, right? So, as you know, literature review has multiple things to do, starting from finding the research papers. If you have a like anchor paper or a starting, you had to find all the other connected related papers. And then you should be able to summarize things. You should be able to put things together, like connect things together. How do we and then group them into like classes, classify them, categorize them, all sort of different things you do in a literature review, right? So all that, there are now tools to do this work. Like, so some tools I just have highlighted. Elicit is one very popular tool. I'll show you quickly what it does. Connected papers is another one. Cite is the third one. So these are separate tools designed just for doing literature review, right? Nothing else. And these tools, the good part about these tools compared to something like a generic ChatGPT is that these tools are trained only on research archives. So they are trained on research papers only. So the answers they give come from the research papers. And the references they give or the references they cite are real research papers, right? So not an imaginary research paper ChatGPT can create. ChatGPT is good at creativity, supposed to be good at creativity as well, and therefore it can create papers. It's supposed to be a feature, not a bug, right? So it's not a problem. It's supposed to do that. So these tools can specifically do that. Specifically create, like find papers, not create papers, sorry. And then you can use generic tools like ChatGPT. When you have such data collected, then you can use one of these tools to brainstorm, right? So brainstorming, in fact, ChatGPT, even remember, even the students were saying, like the highest number of students were saying they are using it for brainstorming, sharing ideas. Normally what will happen, we will do together. Brainstorming people like research groups, research students, supervisor and student, and senior colleagues and juniors. We sit together and do brainstorming. Now, in addition to that, we also can use a tool like ChatGPT to do brainstorming. But to start brainstorming, we don't start from zero. We start from some collected information, right? So that we can do with the previous one. I mentioned about Elicit. So Elicit tool works like this. It's a separate website, elicit.com. And the website has, actually it's a commercial product. There is a free version. Free version has only limited support. It only gives you 4 papers at a time, the free version, if you want more papers at a time. So by the way, what it does, you can give a research question. It can list you down the best 4 papers it thinks connected to that topic, right? It doesn't only list them down, it also summarizes. You can see at the top, summary of the top 4 papers. Actually, you can, if you have a paid version, you can ask for more papers as well. So the summary of several papers put together, right? So that it can do, it can summarize. And it can also do other things, like it can make a summary table. You know, like when you have research papers, we can make summary tables for literature review or other like comparisons and various things. That also it can give you. It can give you a text summary. It can also summarize summary tables. Another useful tool is called connected papers. So what it can do is it can, when you give one paper, it can find other papers connected to this paper. Usually, how do we do connected paper? How do connected paper connections work earlier, before AI, before generative AI? Is that there were graphs, paper-based graph, like this sort of graphs. Graph meaning paper that are connected. So it's easy to draw a graph like that if you take a paper and its references and the citations. We can draw a graph, right? Paper, references, citations. So that is just about the paper and the reference and the citations. This graph is not that. This graph is based on the content. Based on what's in this paper, what are the other papers have overlapping content, and AI looks at the content and decide this paper has more closer content. Even if it is not cited or in the reference, they'll come together, right? So it's not looking at just the references and the citations. It's looking at what is in the paper and then connect the things together, right? So you can make a graph like this, or you can just click on one of these point. A point in the graph is a paper. And when you click it, it again expands into, like, let's say you click on an edge. It expands onto that. That is the center paper. So all the other papers will come around that. It can keep on going like this. And also the graph has some meaning. For instance, the bigger circle means more cited papers. Smaller circle means less cited papers. And then the color, the darker color means recent papers. Lighter color means older paper. So those are all inbuilt. They are in the tool. And I hope you notice the tool, when I click a paper on the right side, it also summarizes the paper, the title, where it is published, a summary of the paper, the abstract. Those items are also coming. By the way, these are all genuine real papers. Another tool is called SciSpace. What this tool can do is you can, let's say you have a paper, a PDF of a paper that you wrote or a paper that you found somewhere. And you can just upload a paper and ask for similar things. Ask for, like, one is you can ask for summary, you can ask to explain some part of the paper, you can ask to explain a sentence, you can ask to explain a particular keyword. And also you can see there's the third item, get related papers. So if you have a PDF, you can give and ask it to find papers which are related. It won't give you a graph. This is not giving you a graph, but it will list down papers. List down papers that are related to the one you upload. In fact, with this, you can also ask questions about a paper. You can upload a paper and ask questions about it. What is in it, and different questions like what's the contribution of the paper, what about the literature review, all those things you can ask. I'll skip that. So that's some extension to the same tool. It does a lot more things. If you are using tools like ChatGPT, it has specific extensions for research. Do you know? Yeah, right. So ChatGPT has what is known as a ChatGPT Explorer or GPTs. So there are people who can go and put specifically build tools within ChatGPT, right? So you can go and search and find them. They are called, there's a search, you can see a search box inside the ChatGPT window. If you go and look for research and analysis, there are different type of topics. Like for instance, there are writing, there is productivity, research and analysis, education, lifestyle, and others. Right? So if you go and find research and analysis, there are specific tools built inside ChatGPT, but they are built specifically for research and analysis. For example, if you take one of these tools and look for inside the tool, if you had to still do the same thing like ChatGPT prompt. Right? So you write prompt, but within this tool, inside ChatGPT. Right? So when you do it, what happens is the answers you get are coming from not, like ChatGPT has, ChatGPT is trained on all the world data, everything that is out there in the internet. Right? But this specific tool is trained, like I said earlier, only on a specific research archive, one or two archives, let's say PubMed or anything else, Elsevier, Scopus, so some place like that. It's trained on one of those places or few places, depends on, if you look at the tool, it will tell you where it is trained. If you can read, like for instance, the very first tool there is called Scholar GPT. It says enhance research with 200 million plus resources and access Google Scholar, PubMed, bioRxiv, archive, and so on. So those are the places from it is trained, right? So specific tools within, right? So there are more tools. I'll just skip a couple of them and move on to some other type of tools in the interest of time. Anyone who is using research tools now, like for example, in engineering, we use MATLAB a lot for doing research analysis and drawing, like doing some data like analysis, like R, we also use MATLAB. So now tools like MATLAB has a chatbot in it. It is called AI Chat Playground. So MATLAB, earlier we used to write code. Do this, draw a graph like this, and compare it like this, do a correlation analysis. All that we had to do code. Now we don't need to. We can write it in English. Here is the data, give me a correlation analysis. Or do a comparison between these two set of data. Anything else, anything statistic, anything that you want. Like in fact, like MATLAB has a lot of engineering simulations and whatnot. Not just engineering, but in engineering also, physics and whatnot. So all that you can now, by just chatting, you can get them done, right? So you don't have to write code anymore. So MATLAB is just one example. You can think of many other tools. They do similar things. Even if you want to do data, like I said, analysis, there are tools for doing it. There is a long list. So this is a list of tools that you can use for data analysis. But I'll just show a couple of them. In the interest of time, let me, one is called PowerDrill. So this PowerDrill tool, I'll just explain quickly what it can do. You can just upload data in a file, like a Excel file or a CSV, a comma separated file. Like so, a set of file, you can just upload the file there, and you can ask a question. So the steps is upload a file, ask a question. What sort of questions you can ask? You can ask against things like drawing a graph or comparing two data sets. Or so that sort of questions you can ask. And it can give the answer. You can download it. In fact, tools like PowerDrill, you can even ask, prepare a report. Compare these two data sets and give me a report. It can do. but you had to like give the right questions and carefully check and all that. You had extra things you had to do, right? So Power Drill can do such things. I in fact have videos about all this, but there's not a lot of time I have to do. Like I told you, I'll share the slide deck as it is. So the videos and all you can watch. It takes a longer time if you want to go through. Another tool is very similar, but it has some really nice data like graph type of generation plus reports is called Julius. So these tools are not all free. They are mostly paid, but they have some free versions. In fact, like all the video demo I have prepared, the videos are there. I haven't played them. They are all generated using free version of the tool, not using the paid version. So I have just covered a lot of different tools and the different places where we can use them. So the good part about these tools are that these tools are designed specifically for that task. And therefore they do those tasks reasonably well, not perfectly well, reasonably well, compared to a generic tool like ChatGPT, right? So you should not, if you are using, you are planning on using any of these generative AI tools for research, you should not use a generic tool, first thing, right? So you have to use one of these specific tools so that you don't get misled, right? So you get, and even after using such tools, make sure you check them yourself, right? So what are the different challenges we have in using these tools? I'll just go through them a little quickly. In fact, I have already highlighted a few earlier. One, these tools are logically not, they don't have a proper logical reasoning. They, in fact, like recently there are discussion between few CEOs of these big companies who are building these tools, whether these AI tools can really logically reason. It's a debate that is happening. So far, they can figure out patterns, right? Whether they can really logically reason, the answer is no, because there are a lot of examples. By the way, every day these tools are also learning better, right? And becoming better, but still they are not logically good. They lack logical reasoning. One other important information is these tools are trained, generic tools are trained from all over the place. And if you take internet, there's more garbage than good, right? You will agree, right? So the good part about something like Google search, is when you search for something, it tells you from where it is coming. So if like you search for a keyword, there are 300 responses. If the first response is, let's say, from a newspaper, second response is from somebody shady's website, we will ignore the second one and read the first one. We can make the judgment, right? But when I ask the same question from a tool like ChatGPT, it's very rarely I get, unless we dig and ask more, rarely know from where the source is. So when you don't know the source, there could be a lot of garbage, right? So we have to be more careful, and that is why these specific tools are very important, right? You reduce the amount of garbage that comes in and make our life easier. So misinformation is problem. And there are also problems like outdated information, because these tools are not trained every day. So for training one of these tools, I told you training, right? So how the training works is you take all the data that is out there in the internet, you collect them and give it to a tool and train. And when you want to make a new version, like ChatGPT now is GPT-5, right? So to train something like GPT-5 completely on all the data out there, OpenAI, they claim they spend about $150 million. $150 million, yes. That's the amount of money they spend to train one model completely on the data. $150 million, yes. Right? So that's a lot of money, yes. So that's what they spend to build. And then that is where like tools like this, the DeepSeek, the Chinese ChatGPT, became very popular because they claim they did the training using $5 million. $5 million, yeah, not a small amount of money. But they became so popular because if those fellas are spending about 150 to 200 million, we can do it in 5 million. So it's a lot of saving, right? So that is how they became popular, and a lot of things happen. You can go and read about it, right? So it takes a lot of time, money and effort to train, and therefore we don't train every other day. So if the last time it would have been trained is a few months back. In a year, you train 3 times, 4 times, not every other day, right? So therefore, the data it has is outdated. That's my point. Like yesterday's work, last week's work, last month's work might not be there. And also these tools are biased, meaning they know only what they know. Meaning, for example, if you take the data landscape of the world, countries like Sri Lanka, our culture, our pictures, our whatever are not there, because we have very little digital penetration in the data space. Our language text, very little in the internet, right? So therefore, in the world of data, Sri Lanka is a small dot, tiny dot. Yes, even in the world map, we are a tiny dot, but here data, we might not even exist, that small. But a country like Singapore, although small, has more, right? So their culture, the way how they use English, those things are there more compared to a country like ours, which is a larger country as compared to Singapore. So that brings in what is known as bias. Bias meaning data that is not ours is going to be used to answer us. If I ask a question about how a Sri Lankan will do, what he'll eat, what he'll talk, it might say something that is not what we are doing because it doesn't know, right? So there's not enough data. So if you ask Sri Lanka, maybe we'll get an answer something of India. India has a larger country, lot of population. They also don't have a lot of data, but that compared to the population and all, they had reasonably large. So they do more. So those sort of things happen in a lot of places. I hope you know what bias means. So that's also a problem. Privacy is a completely another topic, right? So if you are using any one of these tools, and if they are free, you are paying for it by you using it. I hope you know it, right? Whatever the tool you use, if you are using it for free, you are paying for it by using it. Whatever your usage is the payment, right? So if you are doing it, meaning your data is going to be collected for its training and future use and whatnot, right? So all these free tools, even ChatGPT, if you use a free version, they're going to collect all what you do. They'll use it for improving their system and training and whatnot, right? So, so therefore, be careful when you use them, right? So particularly research data, research-related things, right? So in fact, ChatGPT-like tools have revealed certain points. Actually, I can't remember exactly which company. One of those companies' trade secret was public. How? Because the employee has uploaded something to ask a question, right? Want to know something, trade secret, they have uploaded. Employee meaning some few employees who know the trade secret have uploaded to ask question. It has popped up somewhere else. It's a trade secret. So these sort of things can happen to your research as well. So when you are using these tools, if they are free, careful how you use. Paid tool, then you can check. You can ask not to share. In fact, like if you are paid tool, there are option to toggle. Like you can say, okay, don't use my data. It's possible for us to ask. Free ones, no. Right? So what do we do about it? I have mentioned a lot of issues. How do we navigate this space? I'll just highlight a few. One, make sure, like I told you, if you are going to use these tools, make sure the purpose. How are you going to use it? Whether it is okay to use, where to use, how is my data? Is it going to be safe to use in there? Can I afford? And like if I'm going to use research data, I have to be, if I'm going to use some data private, I might have to anonymize it at least. Right? So things like that you have to do before you use. So know the purpose of the use. Don't just go and start using it because it's out there. And there are a lot of factors to consider when you want to adapt and find a tool. Things like price, things like its features, things like why it is designed for, such things. I think I actually highlighted a few earlier. These are again coming from some reports. And privacy, don't share sensitive information. Use generic example, not specific example. Anonymize the data that you use. Check the security of the platform, what they say and so on. Read the conditions. You know, like we never read terms and conditions of any software, right? We read them on for a shampoo bottle or toothpaste, but we don't use for any software, right? So those are because they are too long and you know, like, and there's no point anyway, right? So you're going to use the software. Why do we read? Let's use it, right? So those are, we had to be careful about those in terms of confidentiality. And AI tools, now most of the publishers are accepting AI tool usage, and also there are ways of citing them. Here is something related to citing part of it. APA says how to cite, others also having guidelines. In fact, even we for the National Science Foundation Journal, we have given a guideline how to use and what we accept and what not. So that's also part of the process. There are a lot of gray areas, yes, maybe we can discuss it later, but that also we do. So let me conclude just one message. This is a report graph coming from what is known as this World Economic Forum Future of Job Survey. Last year's survey released early this year. It talks about core skills in 2025. There are 26, you can't read them. I just will highlight the first 10. So these are the first 10 skills. In the World Economic Forum Future of Jobs Survey, last year's survey released this year. Look at these skills. So these skills over time, by the way, the World Economic Forum is publishing this sort of reports for a very long time, several decades, and these skills have been changing a lot. But now the type of skills you see here are very human oriented and generic. And also something that is very interesting is most of these skills are skills we also expect out of research, right? Not skill like papers, yes, we expect out of research, publication, citation, all that we expect, but something we expect more holistically, things like this, right? Analytical thinking, resilience, flexibility, agility, leadership, social influence, creative thinking, motivation, self-awareness. I'll skip the technological literacy, empathy, active listening, curiosity, lifelong learning, right? So these are things that we expect from research. So even in the age of AI, agencies like World Economic Forum have done the study. Actually, the study is done among people. It's a survey report, and they identify these are the core skills for now, right? So I think we still have to do research, not copy paste answers from ChatGPT, so that we can acquire this skill. These skills are what we need, right? So here is just to finish. I wanted to put this slide to tell you that there are different tools. Don't worry about the specific tools I have listed. But the point is, different tasks, there are different tools. AI chatbots are there, code generation. If you want to write program, there are specific tools. If you want to use it for research assistant, I mentioned earlier a bit of them. Elicit, SciSpace, Julius, PowerDrill, I mentioned, they are there. If you want to do grammar checking, there are different tools, image generation, and so on. So there are different tools for doing different things. So know that there are different tools for doing different things, and use those different tools to get at least something that is satisfactory results, right? Otherwise, you will get disappointing results. And when you get disappointing results, hopefully you will give up and do your own. Or if you are being so lazy, you will use them and end up in trouble, right? So start using appropriate tools. And the more important thing is, remember, the acceleration we are getting by using these appropriately is only about 2 to 3 times, not 100 to 1,000 times, right? So the rest of the effort we still had to put. Remember that. So one other golden rule while I'm finishing is that what I advise is, don't use any of these tools if you don't know what the outcome is, what you are expecting at the output of the tool. If you don't know to verify what you are getting as an output, can you read it and verify? If you can verify, perfectly fine, go use them. If you don't know, please don't use them, right? So if you don't know how to verify, or if you don't have access to somebody who can verify, no point of using these tools, right? So that's where we are. And thank you very much for the opportunity. And if you have questions, I can take a couple of, yeah. Yes.
when we are writing a research paper, what about the plagiarism? If we are using the AI tool, what about the plagiarism?
Okay, so the definition of plagiarism, as you know, is about somebody copying somebody else's work, right? So if you want, okay, so let's separate this question into two. One, whether we have ways of identifying someone has used AI tools in writing, right? Yes, there are ways. But those ways are again as good as how good these tools are, because those ways, how somebody identify, how a tool, there are tools, there is a tool where you can give a paper and it will say 90% is AI generated or 50% is AI generated. How accurate that percentage is as good as how good these tools can generate things, because they are similar technology. Technologically, they are both similar, generating papers or generating content and identifying how good the paper, like not how good, how much AI generated is very not perfect, right? One. The other one is there are a lot of studies. Even recently, there are studies done to show these AI detectors identify all of us as AI. What do I mean? So AI detectors identify native English speakers writing as people, non-native English speakers writing as alien, as AI, right? Because these tools are trained on proper English people's writing. So when you write something, actually there is a study recently, you had to go and look at that paper, I have that link, that shows that if you are using, they have compared it with some high school or even middle school English students, and the other group is TOEFL exam text. TOEFL exam is written by all of us, as you know, right? So the TOEFL exam test, the AI tool says this is AI. The grade 8 English US students paper, it says, yes, this is people. That is how the tools are right now. So the tools are very subjective. But there are tools, first thing. So the second part what you asked is plagiarism. So we can identify how much is AI generated. Let's say the tool works reasonably okay and we can identify. Second part is, can we consider it as plagiarism? Right? Or you ask whether how much, what is the percentage, right? So my argument is it's not even plagiarism. Why is it not? Is because this is a tool generating something. We are not copied from anybody else. Right? So therefore, it's not plagiarism. But whether a publisher or editor accepts tool-generated content, it's up to the publisher or the editor. Right? So far, based on what I read from all the publishers, because we prepared a guideline and I was reading a lot of different things, is that most of the publishers say you can use AI-generated content as long as it is for improving English, it is for improving structure. And also they are asking you to show what you did, or at least say what you did, declare, keep it transparent. So you have to say, okay, this is what I used AI for. You can't go and say, okay, I gave a prompt and generated a paper, here's the paper, review it, right? So not that, right? So anything, so you won't say it, right? Obviously, when it is transparent, right? So that's the stage we are in. And also, because you asked this question for everybody else, there's this interesting study that's been happening on assessing work, any work, even academics who are here might also need it. Assessing any submission. It includes papers, it includes any other homework, anything else. Assessing things in the age of AI, right? So there is what is known as AI assessment scale. If you go and look for AI assessment scale, there is a website. I think the website itself is called aiassessmentscale.com or something. So where they have, for now, they have 4 or 5 papers published over time in the last 2-3 years. They are talking about how to assess anything, including papers or any submissions, any homework, anything else. When you submit, how to assess, right? So they are talking about different scales. For example, you assess and assessee first come together and decide which scale I'm going to use. 0 means no AI. Like 5 means you can use completely AI and don't even talk about it. There are in-between levels. The next level from the highest is that you can use AI, but you have to declare. Be transparent, use AI as much as you want, but you have to say, these are the places I used AI. These are the texts generated by AI. So you have to be very transparent about it. That is the level, next level. And there are other levels where you can use AI, but when you write it down, you can't use it. You can use AI to brainstorm, come up with ideas, all that you can do, but you write it down. So like that, there are different levels, right? In fact, the latest addition to that paper, because we are talking research, is that now they are talking about a stage where we can use AI to explore further, right? So can we use AI to go beyond what we are doing in our research? Right? Say, for example, that there are examples, like I told you, like AlphaFold did something that we couldn't do. We could have taken so much time to do. So it's possible to see the thing beyond what we can do immediately using AI. That's the latest discussion there. You can go and read the papers. So they are talking about a level where you go beyond. So I used AI so that I'm able to do this advanced, right? So can I go there? So that's the next one. Okay, so these are things that are being discussed in that area.
Thank you for the interesting lecture. I just wanted to ask that, so I've been using Perplexity for a while now, and I used it to get the academic toggle section to get the answers from the academic section. But you said that it's only just making it better like 2 times or 3 times fast. But in future, what if it increases more? And what's going to happen to the academic world at large scale? Like if everyone, so you said that it's only going to get good as much as the tool is, right? The plagiarism detector. So I like to know that what's going to happen to the scientific world at large, because reliability is going to be an issue now. People can't trust whether people are telling the truth or are they generating or whatever. So, first thing I want to know is, what are we seeing like up to 10 years? In 10 years in time, what are we looking at? And secondly, like if you are using these tools, how can we use it? How can we navigate in a direction that doesn't compromise our jobs in future?
Okay, interesting and very valid and concerning questions everyone has, right? So first, when we start using these tools, I'll start from the last question. So the last question is about, that is why actually I finished, right? So I was talking about the skills. This is an AI aware survey, a survey where everyone actually, all who are participating in this survey were informed, think about AI, what's going to happen to AI. Then only these questions were asked. It's like a very controlled set of survey. A lot of people are involved. I can't remember the numbers. So they have thought about it, and the response they are giving, what people has to have is listed here, right? So these are common skills that, like, if you think about it, even when I did my bachelor's degree so long ago, I would have expected all of them to be there, right? But they are not changed a lot. That is what I mean to say, right? So our ability and skills still are the same, but we have to also adapt and also have to learn these tools so that we can do better. Even, by the way, the same survey also talks about the employability, because you just touch upon that point. So the same survey talks about employability. By 2030, the survey says we will lose about 100 million jobs for AI, 100 million worldwide. And the same study also says there will be 200 million new jobs. We don't know what those jobs are. Some of them are, right? So uncertainty, you wanted something certain, and you are curious. So that is why I'm connecting that. So it's uncertain, but what was estimated is you get more jobs generated, created, but the jobs are going to be with the technology, using technology. And the next question you asked is, what if it can go fast? It can. So the limitation now, the tools can go really fast even now, right? The limitation now is us, right? So why that limitation is there is a reason, right? One, because the previous question again you can connect, right? So the question is, when I use AI, am I plagiarizing? If the answer is no, what it means is also what I am producing, I'm putting my name as author, is I am responsible, right? So that is the whole idea. If I put AI as, in fact, like this is an interesting thing. I don't know how many of you know. In 2022 end, 2023 beginning, if you go and look, there are papers authored by or co-authored by AI. Research papers, they are in Elsevier, Scopus archive, some Elsevier journal. They accepted papers saying co-authored by AI. In fact, like I wrote some, not papers, but some small articles. I put AI as a co-author. I did, and not just me, I just followed. Like I looked at, okay, Elsevier, some journal is doing it, why not me, right? So then we realized that's not going to work. Why it's not going to work is who is taking the responsibility. We are just giving the responsibility to the machine saying, okay, it generated it. What does it mean, right? So it means nothing. So then we decided, okay, even Elsevier decided, okay, we will not accept, there are only few papers, not accept AI as author or co-author, not author, like, okay, there's no papers, just AI wrote, obviously, right? So it's people plus AI. Decided, okay, don't accept. But then everything that is written on the paper, therefore, is the responsibility of the authors, right? So whatever it is written, AI generated or not, we are still saying, okay, this part is AI generated, but still you are responsible. What do you mean by that is everything you have to verify. Everything you have to make sure they are right. They are making sense. You are responsible, right? So the responsibility is given to the authors or whoever is writing things. So which also means the question you asked, okay, so can it be unreliable? Can we publish things? They can be done anytime. We don't have to blame the tools for it, right? So even if there's no tool, you can still cheat and you can cheat an experiment. All of these are done. Like if you go to Ethics 101 for research, all of these are there, no? Pre-AI or pre-technology. Even pre-technology, why do we maintain lab books and why do we maintain this and that and all that is because people cheat. Some people, not all people, right? So that's always there. So even now that can be there. Only thing is, only danger is that it's easier now, right? Things are easier now to cheat. Things are easier now to make a video about you and deep fake and whatnot. Things are becoming easier. But otherwise, the cheating and like misusing and those things, only thing is they are becoming easier. They are becoming faster. So if the productivity of writing something become 2 times or 3 times, same way doing something bad. If you want to do something bad, you can also do 2 times, 3 times better, faster, right? So that's what's happening, but still the responsibility is with us. I don't have a crystal ball for 10 years. Yeah. Yes.
Sir, now a lot of researchers are using even Grammarly to reduce the word counts. Specifically, when you get when you have to submit it to another journal or something, that they have certain word limits. Not to rewrite it, but sometimes they use it to reduce the word count in general. Now, all this software has a server, some sort, that according to what you said, that they store your information, right? So before even it goes to the journal editor, your original material is already being put out. So there is a huge chance of the editor actually sending this material through a tool of his own to check the plagiarism. There's a high chance of getting caught, right? Even if you use the tool to do the grammatical mistakes or errors, or to even summarize or reduce the word count. Am I right in saying that?
Yeah, so you are partially right. So Grammarly, for example, if you are using a paid version of Grammarly and if you are paid version of Grammarly is not using your data. So even ChatGPT, the version I'm using, it says, right? So yes, maybe you can't see it properly here. So I'll just, the bottom part of it reads, ChatGPT make mistakes. And the second one is OpenAI doesn't use, it's my name, workspace data to train its models. right? So this is there if you get a paid account, right? So paid account, and also making sure you, I mean, if somebody is giving a free account and they say they are not using it, hopefully we'll trust them, right? So paid account, it's making sense, right? So again, they say they don't use it. Again, we are trusting these fellows, right? They say we are not using it, so we trust. We are paying, so we trust. That's we had to pay and trust. Yes, that's where we are. And that is a common problem, even plagiarism detection and so on. There are cases, I hope you all know, like there are situations where these papers are put into some like plagiarism checkers, and then they are shown in some other places. I remember some cases even here, right? I can't exact, not here meaning not at NSF, but in Sri Lanka. Anything else? All good? Okay, thank you.
Thank you, Professor Agel, for enlightening the audience how to navigate the AI tools in hand without getting overwhelmed. Now we have the next segment. This is done by the editorial office of the JNSF. So once you submit the article, the editorial office handles the submissions, sending for pre-screening and then for reviewing, and then the copy editing parts, always connecting you, the reviewers, editorial board, and to make your work important in the academic world, the editorial office make the attempt to index it as well in the journal. So sharing the experience, sharing what they usually see during the process will make you secure a better chance in publishing in the JNSF. So for now, for that, I invite scientific officers from the editorial board office, Ms. Upuli Ratnayaka and Ms. Bhagya Dasanayaka, to continue the next session. Over to you.
Thank you, Shamika, for the introduction. And good afternoon, everyone. And I think this is actually a good time for nap, but I try my best to keep you awake. Sorry for the technical issues. We will. Okay. Actually, the reason that Journal Publication Division decided to have this session on this today's workshop, because we have seen there are some good research work, papers from good research work, which were recommended for peer reviewing, later get rejected due to very avoidable simple mistakes. And also we have seen authors, sometimes the authors are not getting the maximum benefit from review process. So we thought of educating you in this regard. You know that review process is, it involves many, and also it's really a painstaking process, not only for the author, but for the reviewer, editorial board and editorial office and many others as well. So for your information, I just like to briefly explain what's happening during your article review process. Sorry for the letters and all. Once your paper is submitted through our system, actually, I'm talking based on our experience, but as I know, this is more or less similar to any other journal publication process. Once your paper is submitted, at first we do desk screening, where we specifically check the conformity to our guidelines. And then the papers, if there are not, they don't have any significant deviation from our guidelines, they are sent to editorial board to check whether the paper is okay for peer review or not. Then they were sent to peer reviewers. They are sent to peer reviewers, and then we get the peer reviewers' comments back. Based on the peer review comments, again the editorial board, we send them to editorial board, and they decide based on the comments of the peer reviewers whether the paper should be accepted, rejected, or revised. So several rounds of revisions can be going there. So after the revision, when we again send it to the reviewer, and then based on the reviewer's comments again, especially for major revisions, we the editorial board decide whether it should be accepted or not. So after acceptance, there are some other processes that language editing, where Dr. Gunaratne involved in, and content editing is for technical correctness, and proofreading, and then final editing by the editing chief. So that is briefly our editorial process. Now, as I told you earlier, due to some small reasons, papers are getting delayed or get rejected. So it mostly happened at the submission and revision stages. So at the submission, we find that non-compliance to our JNSF guidelines. I think it's same with the other guidelines too. Actually, we have noticed that more than 80% of the papers that we are getting are not compliant to our guideline. There are different errors in there. So to avoid that, you can read the guidelines carefully and submit according to the guidelines. And there are journal to journal, it is different, but there are a way they have asked how you should provide author details, whether it should be in the title page or in the system only. In our case, we ask authors to provide it in the title page only, because it is a double-blind review process where we do not reveal your identity to the reviewer. So if you place your details in other parts like acknowledgement, some of authors put that their grant number and any identifiable details in the acknowledgement, then we have to manually delete them before sending to reviewers. So all these take time. And then be careful about placement of figures, tables as required by each journal. we asked you to provide, JNSF asked to provide it in the text, but some may ask to provide separately. So based on that, you can do it correctly. And also, this is another bigger problem that we have seen. Authors, we have included in our guidelines that authors should complete their affiliation and names and all, but rarely authors do that. To the online system, because finally when the paper is published, these details are the ones which can be seen from the outside. So if you minimize these errors, the delays are, your delay is in getting, your delays take by your paper is low. And then before I'm going to errors in revision stage, actually we have to understand what is the purpose of peer review. So peer review is actually the reviewers try their best to make your paper, give your paper a good look, improve its quality, and actually don't look at them as monsters. They always try their best to improve your paper. And also some reviewers we have seen, they make comments, long comments, actually using, they have made a great effort in giving comments, and authors also should have a responsibility to follow those comments and revise the paper accordingly to get the maximum benefit. So when you revise the paper, you have to do it carefully, because if you don't revise your paper well, finally it could be rejected. Actually, at the point you are asked to revise the paper, your paper initially get recommended for peer review, and even reviewer has asked for a revision without rejecting your paper, because there's something in your paper which is really important. But if you don't do the revisions correctly, your paper can get rejected. So we have minor revisions and major revision. Minor revisions are the things, small spot correction like words, simple words, and inconsistency of the units, grammar, punctuation. You need to have reword in some places, unclear figures, tables like things. These can be easily corrected, and we usually do not send the paper back to the reviewer for minor corrections. But this is really important because it improve the overall quality of the paper. Now, major revisions. Actually, major revisions, in our case, the Journal of the National Science Foundation, we usually send to 2 reviewers. So when we are sending major revision, we send both in tabulated form. Both reviewers comment separately. So major revisions are not just correcting 1 or 2 points. It just maybe you need restructuring of the paper and revise in depth. So, and also some authors think when we ask to revise the paper, it is just a sign of the acceptance. No, it is not like that. Based on the revised paper, it is decided whether the paper is going to be accepted or not. So, as example, you have to reanalyze data, change interpretations like that. Maybe you have to do literature, more on literature. And some common mistakes I like to mention when you are doing, according to our experience, actually there are misunderstanding about the reviewers' comment, that maybe authors are not correctly understanding what reviewers asked to do. And then they don't address all the comments. And corrections were not done in all applicable areas. As an example, sometimes a reviewer may point a place at, just think in the discussion that your interpretation must be change because it is not correct. You have to give a different interpretation. So we have seen that authors correct at the discussion, but that interpretation also in the abstract and maybe in the conclusion. Those places are not changed. So what happened when we send the paper to the reviewer again, the paper comes back asking for a third round. Or the reviewer might say this is the corrections are not done satisfactory and may reject. So those are the things you have to be careful. And clarification are given in the author's response, but not, we also ask, and I think most of the journal asks you to give a author response, that in the response, the clarification, no answers are there, but not incorporated into the paper. And also sometimes there are arrogant answers. Reviewers sometimes say that this is incorrect, and authors maybe because this is peer review, maybe reviewer may be wrong, maybe author is wrong, or maybe both are right, both are wrong. These things can be there. But when just rejecting it, you don't get any benefit. Rather than rejecting it, you have to formally say that this is the reason that you are not agreeing with that comment. So we can always discuss, then it is sent back to the reviewer, and most of the time those things can be solved without a problem. So I will explain how we should revise your paper. Actually, we feel that authors, because of the tight schedule, once we ask them to revise the paper, we usually give 3 weeks time for a major revision. They don't carefully read the paper, read the reviewer comments. So carefully read the reviewer comments and understand, taking time. And then when we send review comments, comments of the both reviewers, before starting correction, read both of their comments before start doing anything. Actually, because recently we got a revised paper, we sent to reviewers' comments, and then author sent us 2 revised papers. They are not same, they are different. One paper is adjusted for one reviewer comment, and other paper is adjusted for others' comments. Then we ask authors we can't do that, and ask him to combine it. So you have to read both their comments, both of the comments, and also sometimes we send you annotated paper, and that after reading and going through carefully, then you can create in your mind how this paper should be revised, combining all the comments suggested. And sometimes we, other than the reviewers' comments, we also send editorial board's comments. So reading everything, you have to you have to decide and plan how we are going to change, incorporate these changes into your revised paper. And as I said earlier, that some suggestions pointed out in one place, you have to check whether it is applicable for any other places. Then if it is, then you have to correct all the places. And yeah, and also you have to address all the comments. And anytime if you are disagree with the reviewer comments, you can formally inform with facts why you are disagreeing with that comment. And also sometimes when you the revised paper, when you revise the paper, it loses the flow, because they just, if reviewers asked to add more literature, just add literature, and you put in some references, some places, and you lose the flow of the paper. That happens even in discussion section and many other sections. So you have to be careful after incorporating those changes. go through the paper and read carefully, making sure that the flow of the paper is not disturbed. And also that in author response, that reviewers are expected to see what author has done to each of his comment. So that should be clearly mentioned in response sheet, and make sure that all the responses are incorporated in the paper. Actually, this is a example I want to show. This is something that we are usually getting, often we are getting these things, that if a reviewer is saying that number of replication is not mentioned in the methodology, authors actually included that in the paper and comment like that. But if reviewer's number of replication is unknown, then the author put the number here, but not in the paper. So this happened, this kind of thing happened so many times. We have seen that. So if we miss that and reviewer miss that, finally the audience also miss the information, maybe important information. And also, as I said earlier, don't make personal comments and make comments based on the facts. And also do revision satisfactorily at the first round, because once the paper is, I think maybe due to tight schedule and all, some authors are hurried to give it to within the deadline, but we have seen lot of errors are there. Don't do that. You can always ask that JNSF, if an author asks us for a deadline extension, we provide it. I don't know exactly about the other journals. I think they will also provide you with that. But because if it go for another revision round, it takes unnecessary time of reviewers, our time, and maybe high chance of getting rejected, because the reviewers may say this is not satisfactory and cannot accept if you go for a third round. So try your best to do it within first round. And also double check your revised version and ask for time if you need. So these are the main observation that we experienced during the review process at the unit. So if you have any question, you can ask. And about regarding the references, Ms. Bhagya Dasanayaka will explain.
Good afternoon, all. Today, I'll work through an essential but overlooked issue in a scientific publishing, referencing scientific journals following the journal guidelines. Why correct referencing matters? It's because it acknowledges the original source. It gives the due credibility of the other researchers. And also, it prevents plagiarism, which is a serious concern in academic misconductance. And also, it builds author credibility and strengthens the trust in the research. And also it enables the research readers to locate the sources of the references for several purposes. The common consequences of poor referencing in scientific articles are desk rejections, negative peer-reviewed comments, and delay during the production stage. These are the common referencing errors we are experienced in day-to-day life in editorial office. Correct identification of the type of the publication, that means either this is a journal article or a abstract published in a conference or a book such as, and also there are some reference lists which have mixed lists with several using several referencing styles, and also there are some references with missing DOIs and or incorrect DOIs, and also there are incorrect author details, spellings and years and all, and also missing formatting in the reference, that means punctuations, spaces like spaces, commas, and also like italics, and also uncited references in the text and vice versa in the list. This is a major red flag, actually, editors notice, because if you are using that citation as a reference, you have to mention it in both as an in-text citation and also in the reference list. And also there is a common mistake using the improper use of et.al, because some guidelines use et.al italic and some guidelines use et.al not italic. So you have to concern about that also. And also currently we are getting like non-existing references, maybe AI generated or I don't know. So that is also a major red flag, because it can like even a publication, even a production stage article can go for rejection because of these concerns. And also the other red flag is referencing from predatory journals, which can lead to rejection at the final stages also. As you can see in the picture, there are major components of a reference. I hope you all know all these things. And there is an incorrect reference and a correct reference. At a glance, we can't see the mistakes, but so that's why we have to look carefully. Journal guidelines regarding the references. Usually, journals have guidelines regarding the references to ensure clarity, consistency, and traceability. Usually, we can find them in author guidelines or instruction for the authors, and also certain journals have mentioned to use their publishers' reference guidelines. So we can, usually they give us the link, so you can go there and search. And common elements in the guidelines are to which citation style we have to use. And the other one is the reference list formatting, what formatting rules which the journal is expecting you to follow. And also the number, the order of the reference can be changed in depending on the journal. And last thing is in-text citation. It's also can be depending on the journal guidelines. Some may have numerics in-text citations, and some may have author and year mixed style of in-text citations. According to the JNSF, we also, such as other journals, we also have a specific guidelines for reference. In our general guidelines, we said you to follow APA 7th reference style, and also we generally said you to mention all the sources that you are using, because it gives the credibility, and it represents your honesty, precision, and also quality of your work. And also the reference, as I mentioned earlier, the reference list should be mentioned in the list and the in-text citation, vice versa. And there are, other than the general guidelines, we have specific guideline for in-text citations. If we have one author, two author, more authors, or multiple publications by the same author in different years, such that we have a separate rules for each in-text citations. This may change in a separate journal, so you have to look into that when you are searching a when you are searching for submission guidelines. And regarding the reference list, the list, we are expecting you to have alphabetical order in JNSF, and also to follow APA 7 guideline. Based on that, there may be links to help you, to guide you through the APA 7 to make your reference list complete and correct. And also there are examples. You can see if you are using an edited book to reference, so you can use that example. You can see that example and write accordingly the reference. Otherwise, you will have to go for revisions, and also it can delay publication for months, I think. And now with the technology, we can use reference managing softwares very easily. So when, as a first author, when you are starting to write a paper, when you are setting the introduction, when you are doing, even at the beginning of the research, when you are starting the methodology, you can save all the references that you are using into a library. I think each of these can do that. So make use of these user-friendly referencing softwares, and you can, for that, using that library, you can easily load the reference list, but you have to check manually, because some journals have very specific guidelines other than their referencing style. As I said, it automates the in-text citations also, and also formatting of the citations. We have to clearly look, and if it's okay, then that's fine. And also, if we have the library with us, all of our references, if one journal rejects, and then we are going for another journal, we can use that journal maybe require another submission reference style. So we can all switch easily between referencing styles rather doing it manually. So always recheck. Here I have a few steps in preparing the reference list. As I said before, even starting your research, you can identify sources where you collect your materials in order, and keep them when you are writing. You can keep them when you are writing. Ensure each source is credible and relevant, because if we are using a reference from predatory journal, if you are using a method from predatory journal, your entire research work will be damaged, and it's a major damage. So make sure that you are citing good and reputed references. And also record full details once you are collecting collecting data and preparing the library. With all the components, you have to have all the components, and please check for DOIs, whether we can go there with our link and so on. And also for this we can use reference softwares, management softwares. And also after preparing the library, we can check journal guidelines and prepare them accordingly. Then arrange a reference list alphabetically or or according to the journal requirement. And also cross-check them with the reference list. Always cross-check them with the reference list. And also verify the completeness or accuracy. If you have a lab group, you can each of you know what you are doing, so you can share them the reference lists. And if you have 5 group members, the reference list will check 5 times, 4 times at least, before going to your supervisor. So use that tips and make a best reference list, because it may overlooked, but it can cause a severe damage, even rejection. So that's all for today. Thank you.
If you have any questions now, you can put in our officers. I think you must be having, because we experience a lot of drawbacks and mishaps during editorial process. So it's very important to get in touch with our officers here. So if you have any question, you can put it now.
As we near to the end of the session, we value your feedback. How was the program today? What should we cover in the future sessions? So for that, we have prepared a feedback form. You can see the QR codes. You can scan the QR code and fill up the feedback form. You can find the QR code on the walls, to the side of the hall, and there's a one at the on the door when you go out. Please fill the feedback form so we can serve you better in the next session.
So with that, I think we come to the end of today's session. So it's my duty to place a word of appreciations to those who have supported us throughout. So first and foremost, I would like to express my gratitude to the Board of Management of NSF, because we, being the editorial office and the general publication division, we identified the need of this kind of workshop. So we proposed the workshop, and the Board of Management granted us approval to have it today. And I think it is a great encouragement for us. Even it is very useful for all our participants here. And then I must be thankful, and we are indebted to all our resource persons, distinguished speakers here today, starting from Professor Abesekara, Dr. R.D. Gunaratne, staying throughout the day with us, and Dr. Chaturu Jayasinghe and Professor Roshan Raghel, coming all the way from Kandy to, contribute to this workshop. So we are extremely thankful for your valuable time spending with us despite your busy schedules. And I think our participants got a lot of information, and all of your presentations and discussions were very insightful and encouraging and enlightening. So it is enriching your knowledge and skill. So then I must be thankful to our General Public Team, JPD, for their untiring efforts and dedicated work throughout last few days, because we never expected this such of demand for this type of workshop. So even we wanted to accommodate you here, because this is not like a private tuition or kind of thing. So we can't go for like 100, 200s in this kind of technical workshop. That's why we wanted to have it here with a limited crowd. So we put our advertisement first come, first serve basis. So this is really what has happened. So we took here only the top, and others who got late now joining online. We thought of giving this online connection, knowing the importance of this workshop. So from the beginning to end, especially Upuli Ratnayaka and Bhagya Disanayaka, two scientific officers, really work hard, and with our other officers and our supporting staff in the division. Apart from that, all NSF staff members, including audiovisual team and the our photography team, and all supported us. I must be thankful to all. Finally, this kind of workshop would not have been a successful event without you, our respected researchers and authors. So you are here today. It's very encouraging to us. And I think we had this workshop with a purpose. I feel that we serve that purpose, and you gain a lot of information, and you would have get whatever the important essence of your scientific writing skills. So with that note, I conclude and wishing you a wonderful evening. Thank you. So appreciate if you can give your feedback to this workshop.
Recording stopped.